this video is actually for you. This video prepares you not just for the examination, but also equips you with practical skills for your modern ABAP development. So I actually completed the SAP Certified Backend Developer ABAP Cloud certification today, and honestly the hardest part was not even the coding. It was setting up the environment before I could even start. All right, so but once everything was running, the exam was very practical and it focused on real ABAP Cloud development skills. So as a side note, when you want to start the exam, ensure you have the latest Eclipse and ADT tools installed. So this will save you time, because if this is not installed, you will have difficulty creating packages. So now the exam focus on the following skills: ABAP object-oriented and class design. You're also going to create CDS views and access control. You're also going to create wrap objects, determination and field control, exception handling, ABAP dictionary structures, and table types. All right. So now here's the good part. In this video, I have compiled my entire SAP ABAP Cloud learning series into one complete guide. And this compilation contains 9 structured lessons with practical real-world explanations that will help you not only pass the exam, but actually work confidently with modern ABAP, wrap, and business objects. So if you are planning to take this certification, so practice wrap, practice CDS, practice ABAP Cloud development in Eclipse ADT, and of course use this video, okay, because it covers almost everything that you will need, and then understand the setup process so you don't waste time during the exam. So this video will actually help you build real practical skills and pass the exam. And if you are new here, please make sure to hit the subscribe button so you get notified when I upload new videos, and also for the algorithm to share this video to as many persons as possible. So let's get started. So we're going to start with the first lesson. So this course is actually perfect if you are preparing for an SAP ABAP Cloud certification, or you are a beginner who wants to transition into modern ABAP development. Okay, so all the lessons for this series is going to be taken from learning.sap.com, and if you are preparing for the SAP Certified Associate Backend Developer ABAP Cloud, then this series will also be beneficial to you. And so if you see right here, this is one of the learning journey that you have to go through before you go for this certification: acquiring core ABAP skills. So if you right click on this, you are going to see a lot of learning path, deepening your ABAP programming. And so we are going to be starting with learning basic ABAP programming, as this course will introduce you to the basics of ABAP programming. So it is based on the SAP Business Technology Platform. However, the content is also suitable for SAP S/4HANA Cloud as well. All right, we are going straight to the first lesson, and the objective of the first lesson is that we are going to build an ABAP Cloud project. All right, and so after completing this current lesson that we are going to start, you will be able to create an ABAP Cloud project, right? So the major objective, or the learning objective, also includes that after completing this course, you will be able to understand where ABAP Cloud runs on business technology platform, and you can also set up your development environments, and you can also successfully create your first ABAP Cloud project in Eclipse. So the first step is that we are going to get familiarized with our development environment. And of course, we are going to be using Eclipse ADT, or we can say Eclipse and ADT, that is ABAP Development Technology. So to develop ABAP applications on the SAP Business Technology Platform, we first need the correct development environment. And we know that SAP uses Eclipse with the ABAP development tools, also called as ADT. So Eclipse itself is just the tool. It does not contain ABAP. So instead, we connect it remotely to an ABAP system. So if you have not yet installed Eclipse yet, please refer to my previous video where I show you how to install Eclipse. You can go to Yeah, so you can refer to this my video, Modern ABAP Programming, Eclipse ADT Setup and Overview. So the link will also be in the description. You can click on it. So that video will show you how to install Eclipse, how to install the ABAP development tools, and how to verify your setup. Okay, so before we continue, let's quickly clarify some concepts. And the concept we are going to be talking about is what we call the ABAP perspective. Okay, so generally a perspective in Eclipse is simply a workspace layout. So you can think of it like a dashboard that contains different views, such as source code editor, the project explorer, error messages, ABAP documentation, object search, and where use list. So these are all views, and when working with ABAP, we always switch to the ABAP perspective. And so, because there's also the Java perspective, now for us to switch to the ABAP perspective, let's go to Eclipse. You can just go right to window here and then look for the perspective. You can say open perspective. Now I've not yet added the ABAP, so I'm going to just quickly install the EDT once more, then come back and continue. Or rather, we can just quickly do it together. You go to help, click on help, and then go to install new software, right? Then in the work with, we're going to paste the SAP update site URL right here. It's https://tools.hana.ondemand.com. I'll just paste it right there. The full explanation is in the video in the description. Then you have to add latest to get the latest tools. So let's add this, say ADT, then click on add. So what am I adding? I'm adding the ABAP development tools. So I select this, then keep everything. If you are installing tools for SAP, that's not what we are doing right now. So we can click on next. It takes a while to install. Okay, and then we have this. We're going to be installing these tools. So I will just click on next, read the license agreement, accept, then click on finish. So now we have ADT installed in our, okay, not yet. We need to also accept to trust the authorities, then select trust selected. There's another site. If you look below here, you see installing software 15%. So we actually have to wait for this to go down or run down to 100%. So my bad. I was actually checking and saying, okay, why is this not installed? All right. Yeah, patience is virtue, right? So it goes up to 100% and then displays restart Eclipse IDE to apply the software update. So click on restart now. And yeah, we wait for the system to restart. Okay, now you'll see some release notes for ABAP development tools for Eclipse. You have the time you can read on this. And then you can also check by going to Window, Perspective, Open Perspective, select Order. You should see ABAP right here. So we can select ABAP and then open the ABAP perspective. Yeah, so now you can see right here, create an ABAP project instead of create a Java project. Actually, this video is not for installation. I already made the installation video. All right, so I was just trying to explain what a perspective is and what a view is, and I didn't realize the ADT was not installed on my system and I had to do the reinstallation again. Good for those who are just joining. All right, so basically, there are also two types of ABAP projects in Eclipse ADT. So these two main types are, the first one is the ABAP project that will be used for on-premise systems. So for example, you have the SAP ECC or the on-premise S4HANA project. You also have the second one, which is the ABAP Cloud project. And this is used for SAP Business Technology Platform ABAP environment. And I will show you what this looks like. Or SAP S4HANA Cloud. So in this course, we'll be using or we'll be focused on ABAP Cloud project. So if we open if you go right to your browser and just type BTP cockpit, so you should get this. All right. So we're going to be understanding where the ABAP Cloud actually lives. So this is the SAP Business Technology Platform. If you have not created an account, you can just go ahead, click on sign in or sign up as the case may be, like register and create a free account. I already have an account, so I'm going to sign in. Yeah, so I then click on this use free trial at account.hanatrial.ondemand.com. So you then open this tab. So right here, you can just say go to trial account. So of course, during your installation, you'll be prompted to create sub account. So click create a sub account. I have already created a sub account here. What we should know about SAP Business Technology Platform is that this is SAP's platform as a service. Okay, so let's head back to Eclipse. And so to create our first project, open your Eclipse. Let me close the release notes. You can see ABAP Cloud, ADT survey we don't need. Then I have already switched to the ABAP perspective. Make sure you are on the ABAP perspective. Then go to File, New, and then we can click on ABAP Cloud Project. So now, it says connection to ABAP Service Instance, specify the ABAP Service Instance for connecting to the cloud environment, ABAP Service URL. Okay, are you looking for the right URL? You can use the SAP Fiori Launchpad URL of your system, or do you have a service key? Extract the URL from the service key. Trying to use the ABAP Cloud development model in the private cloud or on-premise, create a regular ABAP project. So, okay, the URL, let's go ahead and create the service key. So then we can see the URL from the service key. However, if you don't know what a service key is, what is a service key? A service key actually contains the following. It contains the system URL. It contains the client. It also contains authentication details. And finally, the service key also allows Eclipse to securely connect to your ABAP system on SAP Business Technology Platform. So the SAP Business Technology is the platform, right, where we have our services, our instances, and our applications. So we need to enter the URL. Okay, so if you don't know the URL beforehand, let's go ahead to create the service key and then get the URL from the service key. So you can go ahead and open your SAP BTP trial account. So open SAP BTP cockpit, and then you can say go to your trial account. Right here, you have already created sub account, so you can click on the sub account. So before you create a service key, you need to create an instance, right? So remember the picture we saw? We want to create an ABAP instance, and since the instance is not here, you just click on create. So for an ABAP instance, what is the environment? The environment is an ABAP environment. So this is the service, and then you can just give a name for it, an instance name. So I'll just type ABAP environ. So click on next. Right here it's going to ask you to specify parameters. So just enter the same email that you used to register for this free trial. So I'm going to enter the email, and then you can also do the same. So after entering your email, you are going to click on create or next, as the case may be. So when you click on next, you get the preview. Service ABAP environment, the service plan is shared. Runtime environment, we're using the Cloud Foundry space dev. Okay, so then click on create. It says creating an instance takes a while. Instance creation in progress. All right, so right here you can see that the instance, ABAP environment instance, was created. So remember, we're looking for the service URL. So when you click on the dots right here, you're going to see create service key. Click on create service key. Just give a name for your service key. Give a reasonable name. Say SAPVIC _ SRV. All right. Then you can click on create. So it's going to generate a JSON file for you, and you can copy that JSON file. So, okay, it says created service keys SAPVIC _ SRV, and all you need to do now is just right click here. So we're looking for the service key. So when you click on the instance that we just created, you can see service keys here. So click on service keys. You see the service key that we created. Then you can click right here to view it. So when you click on view, then you can copy it, While I don't want to show you the service key. So when you copy that, or when you're able to open the JSON file, the first thing you are actually going to see is the URL. So I'll just copy the URL and paste it right here without the quotes. Okay, so then you can click on next. So log into the ABAP service instance, log on by using an external browser. So open logon page in browser for users with several accounts. If you're already logged on in the default browser with a user account, which you do not want to use for the new project, then use the copy logon URL to clipboard option. So there are two options here. So right here, you can just open logon page in the same browser that we are currently on, or you can just copy the URL link to the clipboard so that you're able to log on to the page. So I will just click on open logon page in browser. Yeah, so let's click on open logon page in browser. So you have been successfully logged on. You can close this page and continue in the ABAP development tools. So yeah, we can close this. All right, so now we have this new ABAP Cloud project. So we want to specify the project settings for the new project. This is our service instance URL. We have the user ID, and then the client. Then we have the project name, working set. So you click on next, click on finish. So we have a project right here. All right, so we now have our ABAP Cloud project created. So from here, you can go on to create new files, classes, programs, and several things that we can create. Okay, so in summary, you have successfully understood the SAP Business Technology Platform. You have also learned where ABAP Cloud runs, and you have also created your first ABAP Cloud project. So in the next lessons, we'll be working with packages, namespaces, and development objects. So if you find this video helpful, please like this video, share, and subscribe. And of course, I also want to appreciate you guys for your subscriptions. Thank you for subscribing to this channel. And if you are new and want to follow this series, don't forget to subscribe. So in this lesson, we are still learning the foundation of ABAP, but instead of just saying printing hello world, in the last video, we made setup, we made connection to the server, we created the workspace. And we are going to build a more small, realistic console application, something that you can actually use. So by the end of this lesson, you will know what a package is, what are executable classes, because we are going to use one, and then navigating code in the modern ABAP, and also using a simple system information console app. Likewise, you will know how to create and organize objects using packages, understand what is a local versus transportable component, and also, like I mentioned, create an executable class, and then run the ABAP code in the Eclipse console. And finally, you also learn how to navigate and analyze existing ABAP code using the ADT tools. All right, so let's get started. Before we write any code at all, we must understand where our code lives. And so in ABAP, you cannot just create an object anywhere. So what that means is every development object must belong to a package. And a package is simply a container that groups related objects. For instance, you can see classes. These are also objects, interfaces, tables, CDS views. So these are objects, right? And one thing that we must also know is that packages themselves, they belong to what we call the software component, which we'll also see in Eclipse. And all objects are grouped together to form what we call the ABAP repository. Of course, packages, I've also discussed that when I was using the SAP GUI. So you can also refer to my video on that for more explanation. So let's move forward and create our first package in Eclipse. All right, let's go on to open our Eclipse IDE for Java developers. And so we want to create a package. So the package will house or contains all related objects that we will use. All right, so when you open your Eclipse, you'll see that project is not logged on, and you can click or press F5 or select file, and then refresh to reload the resource. So first you can just click on the workspace. This was the one we created in the last video, so click on this workspace. So it's going to tell you log on to the service instance, right? So you can just click on open logon page in browser, and it's going to ask you to log in to your BTP business technology platform. Automatically it's logged me in because in one of the sessions I said always keep me logged in. So you have been successfully logged on. You can close this page and continue in the ABAP development tools. So we can close. All right. So now what we need to do is that we need to refresh so that the packages can be reloaded to the resource. And to refresh, you either press on F5 or you can just right click on the file. And right here we see refresh, loading content. All right. So far we don't have anything. So this is where we're going to create the package. So to create a package, you can just right click on the workspace and then go to new and then select ABAP package. And so it's the name of the ABAP package. So let's just say, remember the naming convention, you need to start with either a Z or a Y. So let's call it Z SAPVIC underscore package. All right, to give it a description, let's just say my first ABAP package. All right, so we click on next, and here we need to select the software component. So here you click on browse, select zLocal. So we are selecting zLocal because as of now, you cannot create transport requests in zLocal component. So of course, in previous video, or if you go to the sap.learn.com website, in their tutorial, when you create zLocal, you can also still create a transport request. But at the moment, things have changed. There have been an update, so you cannot create transport requests with zLocal component. So zLocal packages are just meant for learning and local development. So we can click on OK and click on next. So software component is zLocal, still click on next. All right, then we get this message. zLocal is not a valid software component for package Z underscore SAPVIC underscore package. Okay, so let's go back a bit and let's assign a super package. Let's call the super package zLocal. So this is generated package for zLocal so that we can have access to zLocal, right? So then click on next, one more time click on next. Now we are in the request or transport request screen. So here, like I was trying to explain, choose from request in which I'm involved. And so in a real system, you'll be able to create a request. But since this is a development system and then we're using zLocal, which before now, you will still be able to create a transport request for test purposes. But as at when I checked it on the community page, this has been updated. So we cannot create transport requests under zLocal software component. All right, so click on finish. So I'm taking my time to explain some of this concept because since you're a new subscriber, I know that there's someone behind the camera. So I'm adding more intentionality to my videos now. Okay, so here we have the general data for the package. So this is the package that we just created. Super package zLocal, the package type, we're in development. The software component is a zLocal, and this is the person responsible for it. All right, so you can check properties and click on properties here. You'll see the package name and the software component. All right, and then the description. You also see the ID of the person responsible. If it's another system, you see the username, then the date it was created, the person who last changed this package, the original language. All right, so all this you can find under properties. And so after creating this, the next thing we need to do is that we need to add this package to the list of favorites packages. All right. Okay, now you see that I have lots of packages here and there could be more than this. So you might not be able to locate where the package is. And there is what we call link with editor right here. So this will link what you have on the right hand side here to the location in the project explorer. So if I click on this, it's going to show me the location of my package. And remember, what I want to do now is to add it to the list of favorites. So I can just right click and just select add to favorite packages. So When you do this, you'll be able to see it under favorite packages. Right here, you can see Z underscore SAPVIC underscore package, right? So there you have it. You have created your first package. And the next thing we are going to do is that we are going to create an executable ABAP class. Okay, now we are not doing a hello world. Normally, you just create a class, print hello world, and voila. In those days, they'll say, congratulations, you are now an SAP developer, or you are now a programmer after writing hello world. It's way bigger and larger than that. However, let's do something more beneficial. You're going to print the system information, the user information. So now to do this, we are going to create a class, and the goal is simple. We are going to show that the program is running, and then we are still going to keep the code very basic. Normally, this kind of programs, when you create a program or write a program in using the SAP GUI, it will be displayed on the screen, right? But with Eclipse, we are going to display it on the console using a particular class interface. You will see all this shortly. So to create a class, what we need to do is that you go to your package, use a package, right click on the package, and then go to new. Just as easy and simple. Select ABAP class. So what I'm going to call the name, so let's just say ZCL underscore, let's see, SAPVIC underscore system info. All right, so this is the name of the class, and the description will be simple system info console app. All right, so now we are going to add an interface. So more explanation about this will come up. So this interface actually makes the class executable in Eclipse, and the interface is this if underscore ooadt underscore class run. So if you see here, you see further description. It says implement this interface to execute an ABAP class. So you click on it, and then we are going to extend the method inside the interface. Then click on next. So like we established earlier, this is a local development and no change recording enabled. So we cannot create a transport request. So for those of you who do not know, transport request is used for transporting objects from one system to another. There are three types of systems. There are the development system, the test and assurance system, and also there's the production system. So the system that we are currently using is the development system. So right now, we do not need to create a transport request, even though SAP has somehow disabled it. All right, so click on finish, and there you have it. We have the class. So I can just zoom the text. All right, now even right here, I have Joel here. Okay, so in the next video, I'm going to make use of the second workspace because I have access to Joel, which is the AI assistant that SAP provides. So I'm going to use that in the next video. All right, so this class is very important. The interface if ooadt underscore class run, and the reason is because in modern ABAP we do not rely on classic reports. So executable logic is handled through classes. So classes are your best friend. And so this interface provides us a main method. If you go right here, method, there's a method here under implementation. Of course, we're going to explain what classes are in subsequent videos. So just follow how we run this first example. And so these main methods will act like the entry point of the program, and it will allow Eclipse to run the class and then show output in the console. So we are going to extend the interface by writing our own code inside the method for the implementation of this interface. All right. So, and I'm just going to paste the code and then explain to you. All right. So first and foremost, after typing, you notice that you need to format your text. So you can just use Shift F1 for Windows users. And then you have it, our text is formatted. Okay, so what this is doing is the out keyword, and then write is going to write this to the console, modern ABAP console app. All right, so I'm going to explain this piece by piece. I'm going to explain this piece by piece. So this is called an expression. I will also cover this in subsequent videos. And so inside an expression, you can keep a text and then a system variable. So this sy-u name is a system variable. As you notice, we did not define any system variable, and this will print out, it concatenates the user text here with the system username, and likewise system sy-system id, and then month is the client id, right? So this is concatenation of text with system variables, and the out keyword using the method write. So we will print this to the console, right? So let's save this. You can just do Ctrl S to save. You can do Ctrl F2 for syntax check, all right? Or you can click on this symbol here for syntax check, and you can see below here system info contains no error. And then, like, you do syntax check, you save, and then you activate. Just activate the program here. Right here, system info activated. And then to execute the program, you can click on this green button here, run as, or you can use your shortcut F9. So let's execute, select ABAP application console, and then click on OK. So right here, we see it on the console, the output. So you can see here that we want to write modern ABAP console app, the user. This is the user ID for the system. Sorry, the username actually. And then this is the system ID. And then this is the client ID. So in real life, you actually have the username and the system ID for your system. Okay. So what you should take from here is that this is a system variable that prints out the current user, and then this this is a system username that prints the current user. This is a system ID, and this will print out the client, right? So instead of just writing hello world, this is much better in my view. All right. So of course, as a beginner, one thing you also need to know is how to navigate the system. And now we switch our focus from writing code to reading and navigating code. And this is actually important in real projects because most tutorials out there, they don't actually teach you how to navigate. Okay, you don't have to actually memorize things. You need to know how to find things and where to find them. Okay, so let's use an example. We are going to analyze a class, and this class is small, stable, and easy to navigate. So it's not that complex. So we are navigating the class so to get a feel of how to go around the Eclipse system. So if you want to search for a global class, okay, a class that is generally available, you can click on Ctrl+Shift+A, right? So when you click on Ctrl+Shift+A, it brings a field for you, enter search string or filter criteria. So I want to use this class as an example. You can either put the whole class name, or you can just put some part of it, and then it also comes out. So these are test global class that we're going to use. So in real project, you can have multiple classes and then you can test with it. All right, so now the class is open on the right-hand side. And remember, as explained earlier, the file explorer location for a file, it's difficult to locate it. So what do? You click on link with editor to give us the location in our project explorer. Okay, so this is actually not in our own package, so we will not be able to find the location in our explorer, but it's a global class, and that's how we are able to see it. Okay, so when you have a class, what are the things that might be useful or necessary for you to inspect? The first thing are the administrative data. So you want to know the properties of the class. I've already covered this in the earlier session. So if you click on properties, you see that the package for this class is SAPVIC convert. So if I actually want to add it to the explorer here, I will just need to copy this. So copy the package, and then let's go look for, you click on Ctrl+Shift+A right here. Let's look for the package and see if we're going to find it. Yeah, so this is a package. You click on the package, and here we have it. This is a package on the right, super package basis development. So let's try again if I can link it to the editor. Okay, still not possible to link to the editor. All right, okay. So the package SAPVIC_convert is the package name, and the version active. This is the description. Hilfsmittel für Zeichenverarbeitung. That's German, and this is the person responsible for it. It's an SAP class. It was created in 2000, year 2000. And then, yeah, you can also see the original language, the original system. So these are the administrative data. So if you want to know who created the class, when it was created, when was the last change, then you go straight to the properties tab and it will give you this. So this is also useful in large systems and team environment. You want to know who created this class that is destroying the whole system. All right, so the link is not working here, but if we have it in our own package, as favorite package, then we will be able to link to editor. But since this is an SAP class, we are unable to link, all right? But this link to editor is very beneficial. So when you want to, you have an editor at the right hand, you have a program at the right hand side and you don't know where it is in the Project Explorer, you just click on this editor right here, link with editor, and then it takes you straight to the location. So the next thing I'm going to look at is the ABAP language help. So for instance, there are keywords you don't know what it is, then you just place the cursor on the ABAP keyword. For instance, let's say this string, and then just click on F1. So ABAP language help, loading information. All right, it took forever to load. I cannot pause the video. So that's one thing with recording. Sometimes we show the most interesting part for viewers. So the F1, if you just hover on a constant or a keyword in ABAP, then you just hover over it and click on F1. And so here we get the ABAP language help, and this is standard ABAP. You can see here that this is ABAP programming language. It's a string, and ABAP environment, string built-in ABAP type, ABAP dictionary, string built-in data dictionary type. So if you want more information, you can just click on this, and then more informations are given here. So here you can see string is a variable, string as for type character. So that is how you can get more information about keywords that you're not familiar with. So here you can see an example, data declaration flag type of character, length 1, HTML type of string, right? So this is an example. Of course, there was a warning that the programs extract presented in the ABAP keyword documentation are only syntax examples and not intended for direct use in a production system environment. So the source texts of the examples are primarily intended to provide a better explanation and visualization of the syntax. So you are not expected to use this in a production environment, right? So these are just examples. So in summary, F1 gives you more information about the keyword and opens the official ABAP documentation. So you don't need to memorize ABAP. You need to know how to navigate. Okay, so and if you press F2, the ADT shows information without leaving the editor. Okay, for instance, let's say you want to know what is the value of a variable. So if you highlight on the variable, let me look for one of the variables here. So let's say system language. All right, so just click on F2 and then you get additional information without leaving the editor. So this sy-lang, which is language, is an ABAP system field, language key of text environment, and then the component type, the data type, the field label. If you have done ABAP before, you know that when you have created a data element, you give field labels, short description, medium description, long description, and the heading. Okay, so the F2 gives you additional information. If this was a variable, then you are going to see the value. Okay, all right. So alright, welcome to today's video, and in today's video we're going to ABAP basics for modern ABAP programming, and it's more like a crash course. So how to read basic ABAP code, understand what variables are, data types, what they really are, and then we're going to also follow the program logic. You also learn debugging. So the idea of this video is that I still see a lot of beginners still using SAP GUI logon screen for their programs. So we are creating this course and going through this tutorial also to make it possible for beginners to learn modern ABAP programming. This is actually a foundation of everything that you need to get started modern ABAP programming. The next class or the next lesson, I'll be showing you how to work with classes. We define the global class, define local classes, we define the attributes, make private attributes, make attributes public, and also how to instantiate a class and so much more. So if you are interested in this series, don't forget to hit the like button, share, and subscribe. So when you know a lot of code snippets and what they do, if you see many lines of code, you are not scared, and then you can actually follow program logic and understand how it works. And of course, debugging is what makes you a developer. So we're also going to look into how to debug code. So we are going to start with the rules. Remember, the rules that can save you hours of debugging. So why should we start with rules? Before we write any logic, actually, we need to understand how ABAP expects us to write. And these are just simple rules. And if you don't follow this rule as a beginner, it leads to 80% of the errors that beginners have. So let's start with the first one, rule number one. Rule number one, ABAP statements start with a keyword and end with a period, which is like a full stop. So for example, you see the keyword data, and then this is a variable text, and this is another keyword type and string. If you don't know what this is, just hold on, I will explain in some minutes. All right, so what I want to show us in rule one is that it starts with a keyword. So for instance, if you want to write a statement, ABAP is like a sentence, and the first thing that comes is a keyword. In this example, we are declaring a variable my text as a type of string. So this is a keyword, and you have to end it with a period, a full stop, right? Okay, so rule number two. The rule number two is that ABAP is not case sensitive. All right, so if you are declaring a variable, for instance, we have data name, which is a type of string, and data name type of string. You see that the name here has a capital letter N, and here also we have a small letter n. This is not case sensitive. All right, so but as developers, you must follow conventions. So clean code is for humans, not just for the compilers. So all right, let's look at rule 3. ABAP is strongly typed, and this means that every variable that you define has a defined type. Okay, it must be typed. So ABAP knows exactly what kind of value holds. So what this does is that it will protect you from mixing text and numbers. It also protects you from unexpected calculations. So we're going to look at how the different typing of the variables are done in some minute. And the rule number 4 is comments. Comments are your best friend. So you can do a full line comment by just putting an asterisk at the beginning of the line, and then you can do inline comments by putting double quotes in front of the text you want to comment out. All right, so we'll look at this in practice. Okay, so the system will ignore comments, but the future you and your teammates will thank you, because sometimes you feel that after writing some line of code, come back later and you don't understand what you did. So you can add comments to give more description, some backgrounds to what you are trying to do. Okay, before we go into the Eclipse and to play around with what we just learned, let me also explain to you what it means by data object and data types. So what is a data object? A data object is actually a named box in the memory. You can think of it this way. So this box, it has a type and it can hold one value, exists while the program is running. So you can see there are different types of boxes here. So this could signify that there are different types of data objects. So each of the boxes has different types and they can hold one single value. All right, so for instance, if you look right up here, this is the syntax for data declaration. You're going to have data, then you give a variable text followed by the keyword type, and then the type of data object string, and then you have value above. So right here you can see data means that creates a data object. So this can be understood as data declaration. Then my variable is the name of the box that we said initially. So then the type string, this is the kind of value that it can hold. If you are familiar with programming, you know that the string is text or characters. Then value above. So this is more like giving a default value, a starting value for the string. And the thing is, you don't always need value, but the type is mandatory. So type is mandatory, value is not mandatory. And of course, they are also built-in types. And we're going to do the live demo now. So we can have string type, type I, which is integer, type D, which is decimal, type C, which is character, and then length of 10. So what you are saying is here is that you are defining the variable to have a type of character and the length to be 10. And then right here we have type N, which is number, and then length of 10. And this type N is something like, for instance, you want to define a telephone number. You know, this is not normal integer number that you have counts, but these are numbers. Or you want to define something like social security number or tax ID. And then data variable type packed. So packed, this P means packed, is for floating points. So for instance, you can have 8.50 and then decimal 2. So this 2 means the number of decimal places you have in the figure. All right, so let's go to the live demo. So from previous video, you already know that we need to create a class. Okay, to run a program, create a class in Eclipse. Right click on your package. If you don't know how to create a package, check the previous video, lesson 2. So go to new, go to ABAP class, and we just give a name to this class. So remember that the naming convention has to start with Z, so I can say Z underscore SAPVIC underscore ABAP basics. So this will be the name of the class, and what will be the description, data logic, and error debugging. So this file will contain all our live explanations and live demos. Now for us to be able to run the program in Eclipse console, we need to extend the interface for this particular class run. So I already covered this in previous video. So we just get this interface if underscore o underscore adt underscore class run, and then click on OK. So click on next. We are unable to create transport request at the moment because this is a local development, and let's click on finish. So here we have our class created. If you don't know much about classes yet, don't worry. The next video we are going to look at how to create classes, class definition, class implementation. And so for the purpose of this lesson, we are going to extend the method in this interface. Inside the implementation is where we are going to write our code. All right, so what I'm going to do, I'm going to paste the code right here, and then we uncomment and go through the explanation together. The reason for this is with AI code anymore, but the fundamentals is very important. So when you understand the fundamentals, when you look at the code, you're able to understand what is going on. And that's why this tutorial is very important. Of course, as at this point, many persons will say, oh, because AI is taking over, you don't have to learn how to code, you don't have to go through tutorials, but that is wrong. Because if you don't understand the fundamentals and how to navigate and how the logic flows, you will not even be able to understand what AI is giving you in the first place. All right, so let's get the data declaration text, and then we'll comment and see how it operates. So this is data. We are declaring my variable, my var, as a type of string. And so if you want to print this out to the console, you could see that here I have auto completions, IntelliSense. This is not available when you are using the classic SAP GUI screen. So there is no IntelliSense whatsoever. If I go to display mode, if you are typing, okay, there's some kind of IntelliSense anyway, but yeah, but not as much as we have it in Eclipse ADT. All right, so you get some IntelliSense based on what you have typed so far, or based on the objects that you have used so far. Okay, all right, so now to print out this my variable, we are going to use a method, right? And then you just say out, and this arrow mark here means instance component selector. So this is more like a reference variable, and this is a method for this class. And then we pass in the text that we want to be printed out on the console, and in this example the text is my var. However, at this point my var does not have any value. Okay, so my var has no value inside. So if we print this at this point, we are going to get So let's see what we're going to get in the output. Just control save, check, activate. So right below here you can see the console. The console is activated, so we need to run. When you click on run, yeah, you have to make sure the executable class. Click on run, then select ABAP application console and OK. So we get nothing in the output. So let's just test and print out a normal text. If you want to do formatting of your text or syntax, you can do Shift F1 and see that this is properly formatted. So I want to just print out text rather, let's say initial value. So without me declaring or initializing the variable in my var, so what do we have printed on console? Let's check one more time. Check contains no error down here. Then activate. You can also use your shortcuts. So Control F3 is activate. ABAP basic activated, and let's run this now. Now we see initial value is nothing, right? Because we have not initialized my var. So but when we come here and said okay, down here my var is equal to hello user. Okay, remember at the end of every statement you put a full stop or a period. So let's Control F2, check for error, wait, then let's run this and see. Yeah, so now we have it printed on the console. Initial value is equal to hello user. Anyway, I'll show you a better way to concatenate expressions in the next few minutes. Okay, so this is just an example of how we can initialize our variables using the keyword data. So likewise, you can uncomment this. So what we're going to do is let's edit these parts and say initial value is equal to this. Then right here we are going to put other variables to play around with the other data types. So my var, we want to look at integers now. The second one, line 1, is type I, integers. So I can say my var equals to 35 period. Then let's print out this. You can see the autocomplete or IntelliSense giving me code snippets, most likely because of Joule. I have access to Joule here. All right, so let me know in the comment section if you also get these auto completions on your normal Eclipse account without Joule. Okay, so tap and it gives me code suggestions and complete the code for me. Okay, so what we are doing here, I think it's done it twice. What we are doing here is that the first time it prints the initial value, okay, the initial value of the variable, and then move this. Then what we do next is that we give a value, and right here we can say value after assignment. All right, so the equality sign is actually the assignment operator. So that means whatever value, this is a string, I'm not looking for integers, it should not be in quotes. Okay, so the value here is passed into this on the left. All right, so this value assignment, so wherever you type my var now is going to have this value 35. Remember what we explained earlier, that it's like a box. The box holds a value and it has a type. All right, so let's save, Control S. Okay, so save, you can do syntax check. So no errors found, activate, then click on execute ABAP application on console, click OK. So now, and I can clear the screen first, you can just do clear and execute once more. ABAP, no, not ABAP test cockpit. So let's, yeah, ABAP application console. So you can see here that initial value is empty, and then value after assignment, that's after we assign 35 to my var, so my var is now 35. Okay, so assignment happens after declaration, as you have seen, and the type decides how the value is interpreted. So you can go ahead and play with, you uncomment these other parts to check for decimal, to check for character with length 10, to check for numbers, to check for pack, and see how you understand this more. All right, so in the third part, we are looking at constants and literals. So just looking at variables versus constant. In the previous part, we looked at variables, and for a variable, the difference is that for a variable, the value change. So constants are important because they protect important values. So if we have values that are very important, making it constant will make it safe, and it also make the intent very clear. All right, so in ABAP, to declare a constant, what you need to just do is to use the keyword constant. Remember the first, it was the first rule or the second rule? Yeah, remember the first rule. ABAP starts with keyword. Okay, so if you want to declare a constant, then you should start with the keyword constants, and then followed by the variable. Let's say constant, something that is constant is your age. Okay, constant my age, you know that is above is typed, so followed by type, and then what's the type of age? You can say int. And for a constant, it's mandatory that you specify a default value or initial value. So for variables, it is not mandatory to specify initial value. So let's say value 25. So if you make it in quotes, then this means this becomes a string. So we are looking for int, so just put 25 and period. So now for us to see, we can just say my var equals my age. So my var, let's just put my age inside my var, okay, so that we can see it. Now this is not formatted, you can just do Ctrl F1 and the text is formatted. So I'm going to comment out this so that when we print, Shift F1 rather, so when we print out my var, we'll be able to see the age. So let's say age, just remove this and say ages. Okay, okay, my age is now, let's see, I can also comment out this. So I think I'm going to mention it in some videos later. So comment, you can comment out the whole line by putting asterisk, but the asterisk sign has to be at the beginning, okay, for you not to get an error. So let's take the asterisk sign to the beginning of the line, then you don't get an error. The second way to make a comment, which is inline comment, is quotation mark, right? So right here you see the quotes here. You can use this anywhere in your code to add a comment, okay? All right, so let's save this. I want to print out my age. Anyway, this assignment is not needed, so I can just read this one. Yeah, I wanted to keep the text. That's why I was trying to play smart, but yeah, just see my age. Remember that in this method, you need to keep a blank space between the bracket and your variable, okay? So if you make this way without no blanks, then you get an error. My statement concluding with my age ended unexpectedly, so you need to put at least one space, all right? Okay, now, so let's save this. Let me clear the console. I wanted this to be a very short tutorial, but my explanation is going into more details because I know that behind this camera is someone who is actually interested in learning. So activate, and then let's execute this on the ABAP application console. Okay, so see my age is now 25. Of course, this is not yet properly formatted. We are going to look at the proper way to format everything and put it in the same line. Okay, very easy, no messy concatenation whatsoever. All right, so this is how you use constants. Okay, so now the next thing we are going to look at is what we call types. So there are local types and there are also global types. So when you use the keyword types, what you are doing is that you are creating a custom type, a customized type. You know, we have built-in types like string, integers, decimal, packed numbers, so characters also. But when you use the keyword types, it means that you are creating your own custom type. Why? Because of your reusability. You want to reuse it multiple times, and then when you want to change something, you change it once and all the variables adapt instead of going line by line to change. So I will show you what I mean in the example. So we want to create a local type. So this local type means that these are our own customized type. I don't want to use the word customized, but custom type. So I put a comment right here and just put asterisk. This goes, this goes, this goes. So what I'm going to do, I'm going to just put a bunch of comment lines, right? And then we can see local types. So now if you want, of course, ABAP start keyword. So you want to custom your own type. You use the keyword types in plural types. And let's say types ty_amount. Or is now the type is packed and it has a length of 3 and the decimal place is decimals 2. Okay, so now what we are doing here is that we are creating a type. So we are creating a type of packed with a length of 3 and decimal places 2. So anywhere we use this type ty_amount, it automatically reuse this declaration. So we now declare now and say data, let's say price. We now carry the type ty_amount. All right, and of course, let's give an example. See, I have some auto completion here. I can just press on tab, and so this will not go because the auto completion gave me these values, but remember my length here is 3, so I'm getting some error. So this is another advantage of using Eclipse, which I don't think this is possible with the SAP GUI. So let's see if this works. Okay, so now you see the same code I pasted here. Even if I take these types and declaration to the top here where we declare variables, you see there's no runtime error detection or during coding error detection. All right, so you only get error detection after you execute the program. So this is another advantage that you get with using Eclipse. You see, because the length here is 3 and I have 1 2 3 4 9, so it's going to throw an error. So to solve this, you have to have a maximum of 3 here, 3 figures, and the decimal place is 2. This is what we declared. So you can say print the price in euros. So if I want to create another data type with these same parameters, I can say, let's say data. So let's say data weight. Then this weight will also be of, okay, let me not use weight. Let's use something that has amount. So let's say shoe size, shoe price, okay? And this type now will be type TY underscore amount, right? So right here, you can also give other samples. So you can have data shoe price with type TY amount, data shirt price with type TY amount, and all these prices with this amount, with this type. So this helps us to reuse it multiple times, like we have done. And when we want to change, for instance, I say, oh, the price is no longer length of 3, we have to make it length of 5, and then decimal places says you have to make it 3. So you just update it to one place and all the other part is adapted to the correction or the update. So instead of trying to, use here, you have to use a type of part, and then you say if it's P length 5, and then you give decimal 3, and if you do same right here, so you see that when there's any adjustment or correction that needs to be made, then you have to make changes for everything. So you get the point now. This is where types comes into the equation. When you want to reuse a certain type, this is what you do. Okay, so let me undo, and of course you can just print out on the console. So let's say shoe price, print out the first one, or let me just copy the other variables. Yeah, shirt price. Let's clear console. Now we are printing out. You could see that sometimes my IntelliSense comes with some things and I say, oh, I don't need it. But if you don't understand the fundamentals, you're confused. Okay, what is this? What is that? And you don't just accept everything that comes your way. Okay, and now it automatically is taking me to create local constants, which I will leave you to do that yourself. Play around. Control S, Control save, and syntax check, Control F2. Now no errors found. Let's click here. If you see right here, you also see some tabs, console, and activate. So when you activate, run, you have to click on this inside this class. When you click on run as, and then you don't see the ABAP application console, you have to make sure your cursor is inside the class, executable class. It's ABAP application. I noticed this several times, so I'm just putting it out there. Okay, so now we have 0 0 0. And why is that? This is because what we printed out are all initial values. Okay, these are all initial values. So there are two ways to make assignments. So it's either you give a default value right here, which you can use the keyword value, and for shoe price, let's say 120.0. For packed data type, pass the value in form of a string, literal. Okay, so let me copy this. It is right here. All right, so you can just change font. Of course, no more than 3, length is 3. All right, so if we now save, Ctrl S and task check, no errors, activate. Now let's SAP application console. So now you see that we now get values in the console right here as we expected, right? All right, so the other part is similarly, we have also global types. So instead of just being localized class, the global types can be used everywhere in the system package. And global types are also defined once. They are used everywhere, and you can press F2 or F3 to inspect the global class. Did I say global class? Global type. So let me comment out all this. I'm done with local types. So to do a full comment or multiple lines, just do control greater than sign into one comments. I believe it's shift and control greater distance. All right, multiple line comment. So I spoke of the global class. All right, for example, we can say data airport type. So this is an example of a global type that is available in this system, and it has a value of MUC. So if you press F2, which we discussed in previous video, if you press F2, you can inspect this, so you can see MO port demo of a global type, right? So we can just go further by looking at some things that you must also know. Literals. So we've used literals code already. So when you have a text that is in quotations, quotes, this is a literal, and when there are no quotes, these are numeric. This actually affects how you do calculations and how you do comparison. For instance, if you want to do 1 plus 1, you don't put the 1 in quotes, so that makes it a text. So if you want to do calculation, then the numbers should be in numeric form without quotes. Okay, so I'll leave you to play with that while we go to the next part, which is making calculations. So basically the ABAP respect math rules, and if we give it a type, it determines the kind of rounding behavior if you have remainders or not. Okay, so for instance, there are also what we call built-in types. There are also built-in types, built-in functions like the square root. So you just need to find, okay, what do I need to do in ABAP? I need to do a calculation, I need to do addition, I need to do subtraction, I need to do division. How do I go about it? And then you can also do calculation. So let's just do some example while you go on and build on that knowledge. So for example, you just want to do a simple calculation. You know you have to declare your variables. So let's say data, let's say 1, type of integer, let's just value 10, and say data 2, value red. Okay, also 3, I. So third one is actually supposed to be results, because we want to add the two numbers and store result. So let's just say result is equal to shift F1, mat the string. So we have this result equals to number 1 minus number 2, print out the result. Then result equals to 1 times 2, print out results, do a division, print out results. So difference between this div mode, modulus operator, this is ratio, this is division, this is modular, and let me save this. Oh, I can't wait to show you guys how to do expression. Expression will make it so much easier to concatenate strings. Alright, so do a syntax check, no errors found, console, then activate, so F3, basics activated, then run program. So this is what I mentioned earlier. If you see this kind of stuff about test cockpit, we don't have console here, so you need to click inside this class, then run again. So you have ABAP application, and there we have it. So our first result, which was here. So now this is actually a good time to even learn debugging, right? So I said we're going to show you debugging here. This is a good time to learn debugging. So result here, we have the first one is 110, which is number 1, number 2, then print it in result. So we get 110. This is subtraction, we get minus 90, 1000, and so on and so forth. So let me just show you how to debug in Eclipse. So what you do is you double click on an executable line, not a data declaration line. So right here, let's say 86, just double click, or you can just put your cursor here and say right click and say toggle breakpoint. So if there was no breakpoint here, it will add it. If there is a breakpoint, then it will remove it. So now you can go on and then hit on F8, or we can just execute from here above application console and do OK. Okay, so supposed to clear, and then it's going to stop at the line that you indicated the breakpoint on. Okay, so let's more time. Then if you go right here, you'll see the debug perspective. Just click right here, and you have variables, you have breakpoints, expressions. So if you go to variables, the results that you want to see, just anyways. Okay, so for some reason debugger is triggered, so usually you have to put the breakpoint at an executable line, not on data declaration. So what we can do, I'm going to restart Eclipse. Let's see this result issue. Yeah, after restarting, connect again to the workspace. Just F5, click on the particular workspace of your choice, get connected, browser. So this was the class that we're working on, then the breakpoint is still here. can double click on this line to add a breakpoint. Let's again as application console. Okay, now we see that our debugger is triggered. So if you had that kind of situation where your debugger is not stopping or it's not being triggered, then just restart. I think this is the second time I'm experiencing this, so it's fine. So in debugging mode, when you just hover on a variable, you see you get additional information. So at this point, the debugger is here. So at this point, result is 0, but inside the number we have number 1 is 10, and then right here you see number 2 is 100. Okay, so then if you look at the right side, you have variables, you have breakpoints, you have expressions. So this right here shows you the local variables, or the variables that are declared in this class. You have var, you have results, you have number 1, you have 2, and at the top right here is, let's see, top, you right click here, show as top level variable. So this right here is top level variable. So if you want any variable to be in the top level variable, you can either right click on it and say show as top level variable, or you can just double click the variable inside the code. So if I want my number 1 to be as top level variable, all I need to do is just double click right here and see it appears here. So right now number 1, the value is 10, the actual type is int, technical description int, then have the system as sub rc variable, which is currently 0. And then if you see number 2, if you hover over it, number 2 is 100, double click, you can see it in the top level variable, right? So now if you want to go a line further, so you click either right up here or F5. So when you click on F5, it goes to the next line, and then this line is executed, and our result is now what? 110. So if you want to see result as a top level variable, right here you can see double click it, show as top level to have 110. Likewise, you can go step by step, line by line execution. Oh, okay, we need to step out. Now we stepped into the right method. So if you are doing step F5, then you are going line by line. If you get into a method, then it goes inside that method. So to step out, if you are inside a method, you either press F7, that's you need to go back, F7, or this symbol right here, step return F7. So we are back, right? So we are on line 89. So we want to go to line 90. So you click on F5 once more, then results, number 1 at this point is 10, number 2 is 100. So but remember, we are doing subtraction now. So the results we see here is 90 minus. So in expression, you can also format it in such a way that you can determine where the minus should be, either in front or behind. All right. So this is how you do step-by-step execution, and then you check the values if what you did here is what you are expecting. So you proceed, do for multiplication, ratio, division, mod. So let's see. Now if I want to just go to line 98, let's see these different types. Let me say, okay, 95 first. So let's click on the line, and then there's a debug button which is run to line, shift F8. So I want it to run to line 95. Then so see, now it just keeps all these lines and then jump up to line 95. And in line 95, we see have result. Here number is 10, number 2 is 10. So the reason why you're having 1000 here is because of line 92, because you are doing a multiplication here. 10 times 100 give us 1000, but we want to know what is the result. So let's go a line further, F5. So now for 10 ratio 100, what's the result? Result is 0. So let's reverse the, so let's say 2, number 2 divided by 1. So let's see if I can go back to line 95 again. So jump to line 95, it goes back. So here we see have the result 2. The result is 0 at the moment. Number 2 is 100, number 1 is 10. So let's go one line down, which is F5. So right now result is still 0. Yeah, so to get more clarity on output, explanation I just said to play a role. And so for result number 2, you can say divide by number 1. Okay, so that will be 100 divided by 10 was 10. Now the data type that we use here is integer. So when the variable result is an integer, it starts 0 decimal part. Okay, this is what I want to explain. This is what I want to explain. So in ABAP, when you divide two integer variables and then assign the result to an integer variable, the ABAP performs integer division. So it will just do the division and return the whole part of the result, no decimal. So they will not be rounded up, it will be truncated. Anything after the decimal point is removed. So that explains why we get zeros in the divisions that we did in the output. Alright, so now for us to also get more insight on the div and the mod operator, you can see what Joel gives an explanation to this. Of course, you can also use the ABAP syntax help, which is, I did it in the previous video. You click on F3, it takes you to, or F1 rather, it takes you to the ABAP syntax definition for the keyword. So, but Joel is faster, is here. So let's see. The code snippet you provided demonstrated the use of the div and mod operators in ABAP. So for a div operator, it performs integer division. So it divides one number by another and returns the integer part of the result, discarding the remainder. So it's basically the same thing as this right here. Just that this is in text and this is in symbol. So why the module or modulus operator mod? It will return the remainder of an integer division, so it is often used to determine number is even or odd. Okay, all right. So these are things you can also play around with. I can show you everything as a beginner. You also need to get into the game and get your hands dirty, right? Enough of the mathematical aspects. Now we are going to the string templates, which of course string processing, and this is the power of modern ABAP. So string templates are actually the game changer when you come to string concatenation. You know, you don't have to deal with concatenation stress or messy concatenations. So, and then when you write with expressions, so your expressions are inside the curly brackets. So when you write with expressions, everything is automatically converted. So this is modern ABAP style, and I'm going to show you in the code now how we do string processing concatenation. So what we have been doing so far is just pure text. So I'll go ahead to comment out these other codes. So I'll be faster now. So it's just easy. What we need to do, let's just text string using data. Then we just say data text as a type of string, and the text, what we are going to print out is we use these bars. So these pipelines or vertical lines, and inside this pipe is where we concatenate text. So you can say text, and then we can pass in variables using curly brackets. We can say number 1 plus number 2. Then you can even say another text zeros. You notice here that there is no period here. You notice here that there is no quotes surrounding our strings or literals. Okay, and then we concatenated with variables. So let me uncomment number 1 and number 2 where we declared, just comment right here. Okay, so you can save, then shift F2, syntax check rather, shift F2, then F3 to activate, shift F3, control F3 to activate, F2 for syntax check, then execute. Okay, of course, one more thing, we need to print out the text. So we can just say out, use the right method just for text right here. So F1 math, just check, activate, execute. All right, see now you see that we have text is equal to 110 euros. So this is the power of expression by expression. Okay, so you have the text variables and this text literals, string literals. Interesting, right? Another thing we can do is that we can also format inside template. For instance, you can do date formatting. So now you have seen how to format text or string, which is the modern ABAP style, game changer. So of course, there are also ways you can format your dates and other numbers. You can check them online. Also, another method of joining string is to use and operator, double and sign, and then this pipe sign will create a space between your two texts or your two strings. So if part 1, for instance, part 1 is hello, and then part 2 is a text or contains user, so it's going to join hello and hello user. So this pipe is going to create a space between hello and user. So if you don't add this pipe, then hello and user will be joined together. So this is another way to join two strings. So because time is fast spent, I'm just going to run through the rest of the slides, and with time or in subsequent videos or in subsequent projects, we'll be able to program the rest or have a live demonstration. So the next thing we're going to talk about is the control structures, which is all about decision making. So we have basically, you have the if and else conditionals, the case and end case conditional. So if you're coming from another programming language, you already know that this is where the program makes a decision. So we have the ifs, the else ifs, we have else statement, and then for every if, there must be an end if. Now, the difference between okay, let's look at the if statement first, an example. So here you see that if score is greater than or equals to 50, we're going to write this statement passed. And so when we have multiple conditions that we want to check, then we add the else if statement. And of course, we check from up to bottom. So the first one that runs wins the race. So if the first code runs, then the rest of the code is not executed. The else is like a fallback plan. Okay. So I'm sure you already know the if and else statement, and we'll be using tons of it in subsequent codes. So don't worry too much if you are not familiar with this. And now the other control structure is the case and end case. So this is more cleaner than the if and else, because when you have too many ifs and else if, best thing to use is the case and end case. So I show you an example shortly. So instead of the if statement, you can use a case and end case. So inside the case keyword and the end case, you put your code. So the keyword when. So when A, execute this line, or you can add other when. You can add other whens if that is allowed. You can say when B, write this code. When C, write this code. When D, right? Then this is the last one, when others, so that you don't get an error. When others, write this, try again, and then use end case. Like I said, the end case, end case is when you have many if and else if, then this is a more better way to execute that logic. Okay, welcome back to lesson 4, and in this lesson we are looking at object-oriented programming in ABAP Cloud. In the previous lesson we have looked at the fundamentals of ABAP, programming in ABAP using Eclipse and the ADT. So, but in this class, to make this real, we'll be building a small project, a bank account class. So create account. We'll deposit money, we'll withdraw money, and then we'll transfer money from the account. And at the same time, while creating this project, we are going to be fulfilling the following objectives. We're going to be defining what is local class in ABAP Cloud. You're going to learn how to create instance of a class. You will also learn how to define and call methods. You will also apply encapsulation for data consistency. So this means that when we create an account or a balance, nobody should be able to mess with the account. And of course, we'll be using the tools Eclipse with ABAP development tools. And alongside, we're also going to be looking at class visibility, public section. You're going to know what this means, protected section, private section. And at the end of the day, you'll be a master in creating classes and implementing classes in ABAP Cloud. All right. Welcome to this channel. Of course, if you're new to this channel, please kindly hit the subscribe button to encourage me to make more videos, more quality videos, and also to reach a wider audience. Analysis shows that 85% of the people who view this channel are not yet subscribed. So please hit the subscribe button, like this video, and share to someone. Thank you. Alright, so now let's proceed. Let's start the coding. Let's create our global class. So I'm going to open Eclipse now. Open the Eclipse IDE, and then we are going to create a new ABAP class, and we give it a name. Created this workspace in the lesson 1. So if you don't know how to create this workspace, you can look at lesson 1. So what I need to do when you just open your Eclipse, since this is a cloud project, we need to always click on or press on F5. Press on F5 to refresh and reload the resource. So I'll use this workspace. So it requires that I connect to the business technology platform or to the cloud. So open logon page in browser, click on this, and then with my details, so you have successfully logged on. You can close this page now and continue using the ABAP ADT. So let's close this. So in previous video, we have also covered how to create packages. So you can also check how to create package in the previous lessons. And now inside our package, we are going to create this class, this bank account class. So I go to classes, then right click on classes. You see right here, new ABAP class. So click on new ABAP class. So when you right click, it automatically placed it inside the package that I have already created. So let's give the name of the class. Remember the naming convention that it must start with the letter Z or Y. So this is the name, lesson 4, bank account, and let's give it a description. So our description will be working with global and local classes through bank account creation, bank account class creation. Okay, that's more than the characters that is needed. You can just say through bank accounts class. Still more. So let's reduce it. Let's just say working with classes through bank account class. So now what I'm going to do is that we are going to add an interface. So we're going to add this interface. This is what we have been using. So the purpose of this interface is that it gives the main method, or let me put it this way, it provides us a main method that will enable our program to run in the console. Okay, so our class will run like a program. So let's add this interface. And then we can select next. So since this is a local object we are creating, so there's not going to be a transport request, but in reality, in real life, there's always need to create a transport request for any project you create. So create a new request. We cannot do this right now because this is a local object you are creating, object repository. So click on finish. Now we get these snippets of the class. So we are going to look at what all this means and how to work with it. Okay, and now this is our global class that we just created. So this is accessible everywhere in the system. If you look down here, you are going to see global class, and then you're going to see local types. So when you click on local types, we will be able to define the local classes. Okay, so local classes can only be accessed inside the same class, while global classes is accessed everywhere in the system. So now we are going to create a local type, a local class. You click on local types, and then you will need to enter the keyword class. So let's start it with LCL, which is like local class. Then you can press Ctrl space. So this is suggestions. So that means we want to create a local class to give us the code snippet. So when it comes, you can double click on this. Now we have the snippet created, the local class definition, and the local class implementation. So definition is where you define your attributes, your methods that you will be using in this class, while the implementation is putting those methods and actions, methods and attributes into operation. Okay, so but first we are going to remove this create private. It's not going to be a private class because we are going to use this local class in our global class. All right, we're going to call it in our global class. So let's say local class bank account, right? So now you have public section, protected section, private section. So this is what we call visibility. All right, so in a layman definition, public section means that anything you define in this public section is available to other classes. Private section, anything defined here is not accessible to other classes. And protected section, we also look at this. So these are visibility concepts. All right, so in our public section, we can have methods, we can have attributes. So of course, we can also define types. So types will create or types are good for clean signatures. All right, and then so first of all, let's define the attributes that we're going to be using in this class, or the types that we're going to be using in this class. So remember, you can define types with keyword types, and let's say ty underscore amount. So this is the amount. For instance, if the user wants to deposit an amount, This is the variable that we're going to be using, and it's going to be having a type of decimal float. So that means it can take floating point numbers. And then the second type is going to be our currency, ty underscore currency. So the type, of course, is character, like string, and the length, we give it a length of 3. All right. Okay, so this is an error, not decimal, so it's decimal float. This is not valid because I wrote class twice, so remove that. And if you have a red, when you have a red line, it means there's an error somewhere. Now, in the public section, after you define the types, okay, then another thing you need to create are the methods. All right. So the methods, these are, you can see them as actions that needs to be carried out with this class. Don't worry if you don't yet understand, just follow me. We'll tie it together at the end and it will be more clear at the end. So methods are actions. So one of the methods that we need to create, or functions, will be called the constructor. It will create a valid object right away. That's a constructor. All right. So now inside this constructor, there are 2 things we need to know, or 3 things: importing, exporting, and returning. So what it means for importing is that what will this method receive? What is it taking? Okay, what are the attributes or values that it will take in importing? So what is coming into the constructor methods? That's importing. So you write the keyword importing, and then you write those variables that you want to create as import parameters. And if you are creating an import parameters conventionally, you can just start with IV as importing variable. So now for the constructor, so when we create this bank account class, local bank account class, we want the owner name to be automatically, or to create a valid object for an owner right away. So who is the owner of this bank account? So we can say owner, right? Owner, and then we give it a type of string. So it's like, what is your name? The name of the person. You can just say IV underscore owner and IV underscore name. So we don't use comma to separate this. And then we go further to create another variable, which is currency. So what is the currency for this class that we are going to this bank account that we're going to create? So you can say ty underscore currency. Remember that we created types here. All right. So that means I was explaining this in previous video. For reusability, we create types. So ty underscore currency, and then we give a default value. So use the word default to give a default value, and then this is euros. Another important variable that we need to create, IV underscore initial deposit underscore initial depot. So this is the initial deposit for the account that we are going to create. So for instance, you want to create a bank account, you need your constructor to initialize these objects right away: the owner of the account, the currency, and the initial deposit, before you can even make transfer, withdraw, or whatever methods that you want to implement. So type will be of ty underscore amount. So for reusability, we created types amount. Then we're going to give a default value to be 0. So you can right click, or rather shift F1 to format your text. Okay, so this is what our constructor method will be taken in, or yeah. So these are the important parameters, we'll put it that way. All right. So now we are going to define more public methods. So this is more like the behavior of the class. Like I said initially, layman terms, methods, actions that you want the class to perform. Okay. So if you want to define a method, what is the keyword? Use methods. So I can decide to put a semicolon in front to have nested methods to create many methods. So if it's just one method, you don't need semicolon. You can just say method and then do what you want to do. So I will say methods is a behavior. So these are still public methods that can be accessible in the global classes. All right, so now the first method that we want to create, what is the first action we want our local accounts to perform? Of course, every account should be able to, you have to deposit money inside, right? So we give the name deposit, methods deposit. And so if you are depositing, what is the parameter that you want this method to take in, to receive, and then process later. So that's what we call importing parameter. So our deposit method will be importing. So what's the name of our importing parameter? To be importing the amount. So IV, importing parameter underscore amount, and the type will be of what? TY underscore amount. We want to deposit amount, deposit money. You take in what? A value, and then this IV amount is what we are going to be processing later, right? So if you deposit money, you are not going to return anything. So that's why this method will not have an exporting parameter. So I will explain exporting parameter very soon, and then we'll also explain returning parameter. Okay, so now what's the next method, the next public method, the next function that we want this class to perform? And the next one will be to withdraw. So our bank class should be able to withdraw money from this class. And so what is the importing parameter? The importing parameter also will still be amount. So if you want to withdraw, you have to state the amount you want to withdraw. So that's the functionality of this class. It takes in an amount. So we're going to say, I'll just copy this. So IV amount type TY underscore amount. So as well, if you just have only one importing parameter, you can put it on the same line like this, since it's just one. But if you have multiples, then you have to separate it, right? You can put it this way on the same line. As well, you can just do Shift F1 will automatically format your text for you. So, but then when we want to withdraw our money, we need a returning value, and we need to return a success message. So was the withdrawal successful? So when you put in the money and then you click on withdraw, was it successful? So we need to return a reply. Okay, so that's where returning value comes in, the keyword returning value. So returning value. So we're going to use inline declaration here. So that will be called RV underscore success. And then the type will be ABAP bool. So this is like the Boolean operations. So either true or false. All right. So this line here, returning value RV success, type ABAP bool. It can also be written this way: returning value RV success. And the essence of this is that this line declares that the method will provide a result that is called RV success. Okay, this is a variable, and this result will just be a simple Boolean value because it's type ABAP bool, which is ABAP true or ABAP false, indicating the outcome of the method's execution. So when you withdraw money, we check what is the value of RV success. Okay, so the next thing we need to do now is to create another method. So if this is just one, so we can just keep it on the same line. All right, so let's create the transfer to method. So we want the user to be able to transfer from this account. And what are the importing parameters? So if you want to transfer from an account, what should this method carry? So the method should have a target. So there should be someone you are transferring to, right? So there should be a target, and also you have to enter the amount. So these are inputs. So these are what? Importing parameters. So we need to define importing parameters. And so you can say IO, which is importing parameter underscore target. And then we give it a type. So this is going to be in reference to our local class. So that will be type reference to local bank account. The reason is because our target is going to be another bank account class that have been created, or another bank account object that have been created. So that's why the type is that. And then we're going to have importing parameter or importing variable, which we already defined, amount, which is type ty underscore amount. And for our transfer to method, we are going to also define a returning value. So the returning value after make transfer will also be what? RV success. So we want to know if the transaction was successful, and the type will be the ABAP bool, which is ABAP true or ABAP underscore false. All right. So we check if the transfer, or we store the value of the transfer of the transaction in the RV success. Now, I will just go ahead, and you have already understood the concept of creating methods, so I'll just go ahead and paste the other methods. So the next method we are going to create is the get balance. So for get balance, we do not need an importing parameter, so we only want to return a value. We only want to return to get the balance that we have in the bank account, right? So for that, this method get balance will have only returning value, and then that value will be stored inside RV balance. Okay, inside this variable RV balance, and then we have the type ty amount. Okay, remember we define types, that's why we are able to reuse ty amount everywhere we need to use amount. I covered this in one of the lessons. Of course, if you are new to this video, I forgot to ask, please don't forget to subscribe to this video, to this channel, hit the like button, leave a comment if you are enjoying this series. Okay, so now the next method we need to create is if you want to know the owner of the account. All right, we want to know the name, the owner of the account, the get owner method. So when you are getting something, you only return the value. So you don't need to add an importing parameter. So we use returning value, stores it in RV owner, and the type will be string. So the next method we are going to implement is the get currency method. So we want to get the currency for our bank account. So the method is get currency, and then returning value. The result of that will be saved inside RV currency, which will be type of TY currency. Okay, so now the next method we are going to create is also the get account method. So the get account method, or get account ID method rather. So returning value, use the keyword returning, and what I'm returning, we're returning value, and that value is saved inside RV underscore ID, and the type will be integer. So this is integer I. All right, now we are done with the public methods. So now what we need to do is to define the private method. So if you go here, so the private section is going to be the section that are private. So this is what's called encapsulation. All right, so those are the methods, the methods that are only accessible within this class but not outside this class. So that's what we define inside the private methods and attribute. Protected section. So for protected section, so anything defined inside protected section will be accessible by other classes that inherit from this class, more like a subclass or derived classes. So if there is no connection between this class and that class, you cannot access the protected section. So the private section, nobody at all can access it except when you are inside this particular class. For the public section, it's accessible everywhere inside the class and also outside the class. All right, so for now we are not going to do anything with the protected section, so we comment it out, and so we're going to go on with the private section to define methods that we are going to use in the private section. So this is where encapsulation comes into the game. So private section is encapsulated state. There will be no direct external access to whatever we are going to define in this section. All right, so let's define the attributes for this class. So if you know data definition, use the keyword data, put a semicolon, put a colon in front if we have several data that we want to define. And so I'm going to define the attributes here to be my owner, my currency, my balance, and my ID. So this means that this can only be set my owner, so someone else will not just come and say, hey, I need to access my owner and then change my owner or change the currency. So that will not be possible. That's why we keep this attribute inside this section. And also here we're going to create a class data. So this class data means that we can access it using the class without creating an instance object. So don't worry, you'll see the difference shortly. So this class data, we are going to give a variable gv underscore next ID, then type will be integer. All right, so now we are going to create methods also inside the private section, and this is basically more like helpers and validators to help us maintain consistencies. So The methods here in the private section will be helpers for validation and consistency. So the first, of course, the keyword to use to create methods is called methods, put a column. And in these methods, what we want to create first, the first method or function we want to create first. No, the first method, there are actually difference between method and functions. So it's a function when it has a returning value. All right. So our first method here is validate underscore amount. And to validate the amount, we need to have what's importing parameter. So you need to put the amount that I want to validate. So we say our importing parameter will be iv underscore amount, which is type ty underscore amount. Then when we validate the amount, we need to get a returning value. We need to get a response. So that will be using the keyword returning, and to return a value, the value will be saved inside rv underscore OK. Inside this is a variable, and it will also be a type of bool. So ABAP underscore bool, so which is like ABAP underscore true or ABAP underscore false. And the next method we are going to create is, does this account have sufficient funds? So has sufficient underscore funds. So if you want to check if it has sufficient funds, then it has to have an importing parameter. So you have to put in a value, and of course, like we have done so far, the importing value will be the amount, and the type will be ty underscore amount. And of course, you can just do Shift F1 to format our text. All right. And we can also, for this, also have a returning value. That also be, let me just copy and paste from here. Returning value that also be saved in RV. Okay. All right. So at the end of our methods, we can put a full stop here, and this is the end. You can say end class. All right. So this is the end of the class definition. So you can say end class. Let me do Shift F1 to format the text. Okay. So now the next thing we need to do is now the class implementation. Actually, if you remove this, there's a shortcut for this. If you don't have this, you have a red line here, and it says class LCL bank account definition does not have a class LCL bank account implementation. So if you need quick help or quick fix, you can just click on Ctrl+1. So put your mouse over where there's a red line, and then just do Ctrl+1, and then it gives you a quick fix. Say add ABAP doc, rename local bank accounts. So right here you can see create implementation for ABAP class LCL bank account. So you can just click, and you can see that it creates the implementation part for class LCL bank account. Methods, bodies for all obligatory methods to be added as well. So you can see that we created constructor method, we created deposit, we created get account ID, get balance, get currency, get owner has sufficient funds, transfer to validate amounts, and withdraw, right? So yeah, let's just, if you click on this, you hit on enter button. So automatically it gives you the code snippets for the implementation part. So like I told you, the implementation is more like activating the methods that we created. So this is just definition of the action we want the class to perform. So methods, just see it as an action. Then for the implementation is how these actions are going to be carried out. Implementation. You implement what you have already defined in the definition class. All right. So now remember, we have the method constructor. We have a method called deposit. So to implement, you just say method, get the method name, end method, and so and so and so. So our quick fix helped us to generate the code snippets that we needed, right? So let's start with the constructor method. And what is it that we want the constructor to do? So look at the constructor. First, it's going to take in these values. Owner, string, which is a name, like maybe a name. It's going to take in currency. Then you're going to take in initial deposit. So if you give me these values, name, let's say Victor, currency, euros, initial deposit, 20,000 euros. What am I going to do with it? So the first thing we need to do, like we said, the constructor is what? It creates a valid object right away. So the first thing we need our constructor to do is that it should generate a unique ID. So generate a unique ID. Remember that we created this variable right here, which is a class data. So it can be accessed without creating an object, okay, or an instance rather. So that is the variable we are going to use and store the unique ID that we are going to be creating. So the unique IDs. So the global variable underscore next ID is equal to global variable underscore next ID plus 1. So this will make sure that the IDs are created incrementally. So no two accounts will have the same ID. Then remember that when we create this ID, we need to store it inside my ID. And because my ID is a private variable, it cannot be accessed outside of this class. So we need to pass in a value into my ID, and that value will be global variable underscore next underscore ID. Oh, okay. It's not my ID, it's my variable underscore ID. Okay, yeah, MV. So you see it's highlighted red. So here it's not Y, but MV ID. Okay. So inside the constructor, the next thing we're going to do is that we are going to set the base fields. All right. So the base fields are what? The variable for owner, the currency, and of course the balance. So these are the private fields: MV underscore owner, MV underscore currency, not MY, MV underscore balance, because this is 0 for now. So MV owner, remember this is a private attribute, so we can access it by creating an object for this class. So the only way to access it is only inside this class. And so that means when we receive in the constructor importing parameters owner, currency, initial value, we want to now set the values for these private attributes using what we received. So this is the point now. Now you cannot just directly send in your values to my MV owner. Okay, you cannot just send in the currency to MV currency. So what we need to do is I will first receive it from the constructor, and then in our implementation we'll then set these private variables. Okay, I hope that makes sense. So that means IV underscore owner, and then it's equal to IV underscore currency. That's importing parameter. So these are the base fields. And then we also set the initial deposit, which is only through the method. And this is consistent rules. So we are now setting initial deposit. All right, so how do we do this? We write an if statement. So if initial deposit is greater than 0, deposit initial deposit. So this is majorly for checks. So if the user sent in initial deposit, for instance, so if it was not a private attribute, then everyone can just set their initial deposit by just accessing the class. So if initial deposit is greater than 0, deposit that initial deposit. That's what we are checking here right now. All right. And that is the end of our constructor method. So let me control save. If I zoom out a little, you can see the whole constructor method. So when we use the constructor method, we generated an ID and then pass this ID into the private variable or private attribute my ID, and then we set the base fields, my own call this my owner or the owner of the accounts, the currency, and the balance. Then we check the initial deposit. And so if initial deposit is greater than 0, we deposit initial deposit. I hope you are still following. Still a long way to go. Perhaps I should break this video into 2. Alright, so that's the end of the constructor method. So the next method we need to implement is the deposit method. So here we check if the amount is valid. So we say if, remember there is a method called what? Valid amount, that takes in the amount value. So now that will help us to check the amount. So if valid amount, what's taking in the importing parameter, you should always keep a space when you are entering values in this method. So if valid amount, there should be a space between the first parenthesis. and your variable. So if valid amount, you pass in the importing parameter amount. So this is what we want to check. We want to check if valid amount IV is equal to ABAP false, then do nothing, we just return. So we return from the methods and if. So if the moment the valid amount is ABAP false, so if the amount passed into our deposit method is equals to ABAP false, then what we're going to do, we are going to do nothing and then leave the method. Or rather, okay, I noticed I was explaining stuff and I did not hit the record button. Okay, so method deposits. Let me just explain it one more time. All right, so zoom in. So for our method deposit, we are going to first check if the amount you're going to be depositing is valid, and if you click on Ctrl space bar, it gives you the importing parameters and returning value for this method. So this method is a public method that we created. If you click on F3, all right, so we check if the amount is false, is equal to ABAP false, then we leave the method. So if this is not false, if it's true, then we set the balance, which is the private attribute, which set local balance by saying MV balance plus the importing parameter balance. So for instance, you want to deposit money, the money will come in as the importing parameter. It will check that amount to validate it. And then I believe I've also explained this, the method for get account ID, then the method for get balance, method for get currency, method for get owner. So what I'm not sure I explained before was method transfer to before my connection went off. So first, for the transfer to method, we need to first initialize this variable RV success. If you click on shift space, you see the definition of the transfer to method. It has importing parameter IO target, which has a type reference to another local bank account class, and then IV amount, which is a type of LCL bank account TY amount. All right, I also have a returning RV success value. So we just initialize the RV success from the beginning to be false. We want to start the transfer. And then the first thing we need to check is that we need to check the target, basic checks the target account if it's initial. So if the place or the account we want to transfer to doesn't exist, then we leave the method. So return, that's the keyword, leave this method. So the transfer will not be carried out. However, if it's true, then the next thing we need to do is to validate the amounts that we want to transfer using the validate amount method. Okay, so that validate amount, if you click on shift and space bar, you see that it takes in the importing parameter as amount, and they also have a returning value. So if we validate that amount and it's false, we leave. If not, we continue with the method transfer. Another final check that we can do is to ensure same currency. So you want to transfer, you want to make sure that the currency of the target account is the same thing as the currency of the source account. So how do you do it? You write an if condition. So if the target, so inside target, we use the get currency method to get the currency of the target account, and then we use the greater than and less than sign to compare with the local, with the source currency. And then if it doesn't match, you leave, you return, you leave the method. And if this checks out to be true, then finally we draw from the sender, then deposit to the target. So first also we need to check if withdraw amount above is equal to true. So because the withdraw amount, if you click on F3, we go to the implementation of the withdraw amount. We had to perform some checks. We have to first see if there are sufficient funds. Then we perform the subtraction of the amount that was imputed into the withdraw method from the current balance. Okay, so if this returns to be true, then we can continue with the transfer. So if withdraw IV amount is equal to about true. Then IO target, which is our target account, is going to call on its own deposit function method, and then pass in the amount that we are going to deposit. And afterwards, we set RV success to be true. And this deposit function, if you click on F3, go to the implementation, you can see here that we did some checks, and then we did the mathematical calculation of how to implement the deposit. All right, so that was what I did. All right, so the validate amount method, this one we have not yet implemented it. So yeah, we are only calling it here, but we have not yet implemented it. All right, so validate amount. So let's implement the validate amount. Okay, so to implement, we can also say method validate underscore amount, then write end method. All right, so if you look at the definition, you can just click on F3. We take in importing IV and return a value. So for our implementation, just this, you can see returning value RV OK. So for the implementation, we are going to first set the RV underscore OK equals to ABAP true. So we initialize the returning value to be true. All right. So now the first validation is that no negatives or zero. So we want to ensure that when we want to enter amount, we want to deposit money, or we want to withdraw money, you should not put minus something, or you should not put zero. So that means we're going to check if the importing parameter, so which is the amount now, if IV underscore amount is less than or equal to 0, then what do we need to do here? We need to say RV underscore OK is equal to ABAP false. So the returning value what will be false. Okay, and that means our method will return RVOK to be ABAP false. All right, we can also check this during testing and check debugging to check the values. So end if, put end if there, and that's so there should be space. There should be space here, so that's why there's error here. All right, so that's the end of the validate method, and that was why when we used validate method here, you see that we are checking if the answer is, if the response or the return value is above false. So if validates underscore amount, I'm passing the amount, it checks the amount here, is it less than 0? If it's less than 0, then returns a false, and if this place is false, our deposit will not take place. I hope the flow makes sense. Just take your time and listen to it again, and it will make full sense. All right, just have the flow of execution in your head. All right, so less than or equal to means no negatives or 0. So immediately the thing is true, then other methods that implement validate amount will run accurately. Okay, all right, so we are done with the local class. I think it's a lot of time, but so let's go to problems. So let's quickly tidy up some errors that we're having. Okay, so here it's supposed to be a period here, and let me do Shift F1 to format. All right, my MV balance is unknown, so here there's a typo here. I can just put balance. Then this one, implementation missing method from has sufficient funds. Okay, so I have not yet implemented this has sufficient funds, but I've used it. So let's do, so if you click on Control 1, it gives you options to fix the error, add implementation for has sufficient methods, make sufficient method protected. So we're going to make it add implementation for sufficient methods. Double click. So the method has sufficient funds. So let's implement that method. So if you hover on this and you click on Control and spacebar, you see what values we have. We have importing values, amount, and we have returning value, RV. Okay. So if we want to check for if the amount is sufficient, whether I want to do a transfer or a deposit, then let's first set the returning value okay to be equal to ABAP true. All right. So we first set it to be true. and then we check, because the sufficient funds is actually checked if you want to make a transfer. So we don't need to check if you have sufficient funds to make a deposit, right? Okay, so we check if MV_balance is less than what we want to withdraw, which is the IV_amount. So if this guy is less than what you want to withdraw, then we have to set the returning value RVOK to be ABAP false. Okay, of course we need to end if, just to shift F1 to format, put a period here, Ctrl save. Okay, and let me give you an example of where it has been called. So inside our withdraw method, we check if has sufficient funds is equal to above false. So which means if this our method checks the funds and is false, then we are not going to perform a withdrawal. We're going to leave the withdraw method. All right. So basically that's all for the local class that we created. Now the rest of the program is going to be in the global class. So click on the global class tab to go to the global class. In the global class, likewise, we have the public section, we have protected section, we have private section. We have already explained that we use an interface for this our class. So this interface has a main method that will help our program to run on the console or in our console. Yeah, of course, first you need a reference variable. We're going to use an inline declaration, so you can say data. So let's say LO_Victor. Okay, so this is the object you are creating, equal to, use the keyword new, and then you call on the name of the class. So we are creating an instance of the local class we just created. So that'll be LCL_bank account. All right, so put open and close brackets, put a period at the end. So I'm going to teach you the new syntax method of passing the values. So here you just click on enter, and if you highlight here, it says no value was passed to the mandatory parameter IV owner. So when you are creating an instance of a class, the importing parameter is always mandatory. So it's possible to create an instance without any values, but the importing parameter is mandatory. Surprisingly, we did not use any exporting parameter in this example, but as time goes on, we'll have a look at that. So let's pass in the values. If you do Control and space and hover here, you will even see the values for the constructor. We have IV owner, IV currency, and IV initial deposit. All right, so what you need to do is pass in your values. So IV owner, we want to pass value into the IV owner. And so who's the owner of this account? The owner of this account is Victor. No full stop, no comma. Go to the next parameter, which is currency. All right, so let's see, IV_currency will be equals to euros, EUR. This should be single quote. All right. Oh, it already has a default value of euros, so we might just not need to pass in the value here. Okay, then let's set the IV_initial depot, so to be equals to, let's say, 20,000 euros. All right, so this is the instance of the class we just created. So we are creating a new class. So this is the owner of the class, the owner of the account, Victor, and then the initial deposit. So likewise, you can create two accounts. You can just copy this, create two accounts so that we can also try the transfer stuff. But let's change the name. Let's change the name LO to Daniel. New local bank account. So the owner is Daniel. Initial deposit also to be 20,000 euros. All right, so we can save this, Control save. So first test. Let's just print out the amount that has been created. So if you want to print out the amount, of course, you know that we can use the out class. We use the write method to write in our console. So out -r greater than sign, then the write. and then put a period here, pass in some text that you want displayed on the screen. So let's see, created accounts. So we want to print the accounts that we just created. Created account. This is writing on the wrong side. This should also be in the class run interface method, so right here. And then I'll bring back my console so that we can see the output. And so we need to print the name of the account and also to get the account ID and also get the account currency. So I'll just paste the text here. So use outright and L0 Victor. So this is the object that we created. I think I should zoom out. Okay. So L0 Victor is the object that we created right here. And if you see hyphen greater than sign get owner. So this is object component selector or instance component selector. So we use this hyphen and then greater than sign when we want to get a method, an instance method. But if it's just a class method or class attribute, we use equal to and greater than sign. So for instance, class data attributes or class data methods. All right, the instance as a return, we get the owner. So get owner puts curly puts let me still zoom in. So this will return the owner, the name, and then we concatenate with ID to give us the ID of this instance. So we say the instance name again, get account ID, and then anytime I want to get anything from this class, Victor get balance, Victor get currency, and so and so. All right, so let's do the same for Daniel. You just copy the same code and just change the objects or the instances rather. So let's see outright. So for the instance, Daniel get me the owner. So it will print out the name, Daniel, and then get account ID. So let's change this to Daniel. So it will return us the account ID for Daniel, which is incrementally generated like we showed in the local class. Then this right here also change the instance to Daniel. And this right here also change the instance to Daniel to get the currency for Daniel. And so let's save this, save all, control save all. And then we can do, in ABAP there are 3 fundamental laws. You save, you check, and then you activate. So right here you can do Control F2. So contains no error. So let's activate, Control F3 to activate. Now it says here that bank account has been activated. Now let's execute. You click on run as and then ABAP application, click on OK. So if you check the console, you see Victor, the ID is 1 and the current deposit is 2,000 euros. All right, so this is second account, Daniel, ID 2 and 2,000 euros. So of course, if you want to debug, you can, I've done a video on debugging. So also look at the video. I don't want this video to get longer than it should be. So you can just go to your local classes, local types, put the breakpoint on an executable line of code. So let's put a breakpoint here. You can just say right click, double click on the line, and then a breakpoint is added right here. Then if you click on, let's save, and if we click on execute again, ABAP application, anyway, the debug is not triggered for some point. Okay, so the other things you need to do is just to print out other stuff to test our code. Right, so we've tested that we can access the get owner, the get account ID, the get currency, right? Then what we need to do next, we need to see if we can deposit money. So the second thing is that we have to call the method deposit, and if you want to do that, you will just need to, maybe I should type this out, call the instance that we created L0 Victor. So I want to call on the deposit method. So just do the instance component selector hyphen and then greater than sign, and you see that you even have auto suggestions. So you can see deposits, you can say get account ID, you can see get balance, you can see get currency. So we want to do deposit, so you click on deposit, double click. So if you call on a method, you need to follow the parentheses with a period at the end, and remember that this deposit method, no value was passed, it must take in a value, which is it must take in important value, it must take in the amount I want to deposit. So let's say I want to deposit 10,000 euros to Victor account, and afterwards we can print out the account again. Okay, let's print out the account again to see if our deposit works. So outright, after deposit of 10,000 euros, Victor balance will be what? Equal to, this is concatenation, curly brackets. You concatenate string with variables using curly brackets, and before then, these are called expressions. Before then, you need to put everything inside the bar or pipe symbol. Okay, so you see that everything is in one pipe symbol, everything. Then you can concatenate between text and variable. You put them inside curly brackets. Your text, your literal, you put them as text as they are. So we now have LO underscore Victor get balance. This is our method get balance, parentheses, close it, and also we get L0 Victor get currency. So we should expect that our balance for Victor will move from 20,000 to 30,000. So let's save this, control save, and then let's activate, or we can let's check problems. Let's do F2 check. Okay, no errors found, so we can activate. Okay, so let's execute now. Run as ABAP application console. Okay, so we can now see below here, after deposit 10,000 euros, Victor balance 30,000 euros. So it works. Now we can move to the next test. So we want to test the withdraw method with success flag. All right, we want to test if our withdraw method works. So we are going to call on the withdraw method. So we say if low, that's the instance we created for Victor, is selector. So we want to withdraw, select withdraw, double click, and then put a period at the end. So we need to pass in a value. Let's say it wants to withdraw 1,000 euros. So if withdraw 1,000 euros equal to ABAP true, then what are we going to, we're going to print out, and then we can say withdrawal. Okay, so the withdraw method will check if you are able to withdraw, and then let's print out the balance after withdrawal. So let's say out L0 pipe symbol withdrawal is amount after withdrawal, curly brackets, L0 underscore Victor get balance, then put this here, period right here, then this pipe should be at the end right here. Should be space between the pipe and the parentheses. Else, because if the withdrawal was not successful, then we need to write an else statement. How to withdrawal of 1,000 failed, insufficient funds, or invalid amounts. Then afterwards we need to end if, put a period. We can as well shift F1 to format. So let's do control save, check, and as well add euros here. So let's activate. So ABAP application console. So you can see withdrawal okay. Amount after withdrawal 29,000 euros. So our withdrawal method works fine. So we need to test, the next thing we need to test is the transfer money. So we want to transfer money from Victor to Daniel. So by using the transfer to method, transfer money, let's put this in Victor to Daniel. All right. So of course we can first check if our object, the instance for Victor, call on the transfer to method. So remember that it takes in the target import parameter, which is IO underscore target. So our target now will be what? First, let me show you. Let's hover on transfer to, click on shift and space. So transfer to what? It takes what? Importing parameter IO target, which is of LC bank account, which is an instance of a bank account, of a local bank account class. So now that IO target, we are setting it now to be the instance that we created for LO Daniel. Okay, so IO target is Daniel, and this must not be initial. So how much do we want to transfer? Let me show you again. So space. We also need to put amount that we want to transfer. So it takes in target and amount. So the amount, IV amount, equals, let's say, 9,000 euros. Okay. So, we apply some checks on the background. So if this Daniel and amount equals to ABAP true, so it first check, okay, IO target is not initial, which we defined in the class. Then the amount, the sufficient amount. So it checks. So if everything checks out to be ABAP true, then we can proceed to carry out whatever I want to carry. So we're going to print out that, oh, the transfer was successful. Transfer of 9,000 euros was successful. Okay. So if it was not ABAP true and it was false, so else maybe something happened, the amount was not sufficient, or there is no instance for the class, so we're going to print out that the transfer failed. Transfer 9,000 euros failed. And then if you need to add an end if with a period, and there we go. So let's add some output text to print out the balance for Daniel and also for Victor. So I'll just paste it right here. So we print out Victor, call on the instance, and then call on the method get balance and euros. For Daniel, we call on the instance LO Daniel, get balance, and also in euros. So we should see transfer of 9,000 was successful, and then we'll see the balance for Daniel and Victor. So let's do a syntax check. Save first, we can Control S. Check for syntax errors, activate, and then we execute ABAP application console. Okay, I set a breakpoint right here for debugging. So when you set a breakpoint on a line and you execute, then you can see the flow of execution. You can see the variables here. I've explained extensively in the previous lesson 3 about this debugging and how you can check. So you can even see now that my owner is Victor, euros, and balance is 29,000. ID is 1, next ID is 2. So you can do step-by-step execution and then see how the code flows. So I'm going to remove this breakpoint. Click on F8. So here is where you can change to debug perspective and also to ABAP perspective right here at the top right. So let's go back to the ABAP perspective. So on the console, you can see transfer 9,000 euros, maybe transfer of 9,000 euros was successful. So my balance now, remember the balance before now, amount after withdrawal was 29,000. So after the transfer of 9,000 euros, Victor now has 9,000 euros. Daniel had initial balance of 20,000 euros. So plus that 9,000 euros, now have 29,000 euros. So that's that with the bank app. We're able to withdraw, we're able to deposit, and we're able to transfer. Okay, so now you can see how encapsulation works. So we made the MV balance private, and so the only way to change it is through when you want to deposit and when to withdraw, when you want to transfer to. So you cannot just use the instance of a class that you created to change the balance of the account. Okay, so in a bank account, the balance must always be valid. So you don't want random code in the program setting the balance to negative or skipping the rows. That's why we made MV balance private. And so the only way to change it is through deposit, through withdrawal, and through transfer. So that's encapsulation at work for you there. The object will protect its own data and enforces consistency. So for example, if balance was public, then someone could just set balance to minus 9999 and then the system will break. But with private data, that is impossible to do. All right. In this lesson 5, we are looking at building a flight lookup program. And by the end of this lesson, you know how to investigate a database table. You know how to read data with select statement. You know what a CDS view is and why it is cleaner than reading just tables directly. And of course, the learning objectives are as follows. You understand how ABAP data is stored in relational tables. You also know how to investigate table structures such as keys, client fields, and columns. You also know how to read data using the ABAP SQL. And finally, you also understand how to use SY sub RC and how to work with empty results. You're going to know how to use a CDS view entity with an association to read related data. Before you actually read the data, you need to know where the data lives, and this takes us to table creation. Okay, so in SAP, the data is stored in relational database tables. The rows are records, the columns are fields, and the key fields uniquely identify each record. So you have a primary key. So this primary key will be known as the key fields. And of course, in modern ABAP Cloud, we define tables using the DDL sources. So that's what we are going to see when we use the keyword define table. So the first table that we are going to create is actually the carrier airline master table. This is the snapshot of the code for the carrier airline master table. And if you see, we are going to create this table. I'm going to show you how to create this table in ABAP Eclipse. So this table will store the airline, for instance, like Lufthansa or the American Airlines. And in the table definition, you'll see this keyword define table. So zflight underscore car underscore 1 underscore I is actually the name of the table. So use the keyword define followed by table and then the name of the table you want to create. Then we have the fields. So key, it means that this is the primary key. All right. So I will explain this in the code. So this is the first table that we're going to be looking at. This is the master, the airline master table. And then the second table is the flight connections table. We use the keyword define. And then you could see the table description here as flight connections table. These are the fields for the table. So, all right. So let's open Eclipse to see how we created the two tables. So this is the first table. So if to investigate a table, for instance, I have this table open and I want to know where it is located in my project explorer, you can just click on this symbol right here, link with editor, and then you can see the location of the table. So we use the keyword define table, the table name to create a table, and then we have the primary key. So this is a client, and then this is the data type. So right here, I'm using built-in data type, which is the client. And then not null means that this is mandatory. So it is not optional field. So for, you have to select primary key if you are using SAP GUI to create a table. And then we have the carrier ID. Also, this is a primary key. So inbuilt data type, not null, is mandatory. And then the carrier name, ABAP.character, length of 40. All right. So now you can see here that data maintenance is allowed. So that means this table, we can perform CRUD operation on it. We can create, we can update, we can delete. And then the table category, this is transparent table. All right. So now if you want to create this table, it's very easy. You go to the package, that you want the table to be created inside, then you just right click on the package, then you go to new. So then you click on other ABAP repository. So right here you can just search for database table. So database table comes out, you click it, you select on next, and then you give the table name. Okay, for instance, this table name is zflight. Remember, if you are creating objects, that are outside SAP, you need to start with letter Z or letter Y. So Z flight underscore carrier underscore 1. And then below it, you give a description. So you can say flight carrier database, right? So after that, you just click on next, you save, and then the table is created. So this table is already created, so I will not want to create it again. Okay, then the second table that I showed you on the screen is the flight connection table. So use the keyword define table Z flight connection, and then you have the fields, key fields, the client, the carrier ID, the connection ID, the airport from, this is the departure airport, and then this is the arrival airports, so our airport to ID. Okay, so these are the IDs, so these are part of the fields for this Z flight. Okay, and if I want to know where it is in my Project Explorer, just click on the link to editor and then look at it right here. Also, you can even inspect the table. If you just right click on the table, you want to see what are the content inside this table, you right click on it and then go to open with, click on data preview, and then it will display the content of the table. So we have this table, client is 100, the carrier is Lufthansa American Airline, then connection ID, then airport from, this is the departure airport, then airport to arrival airport. Okay, so if you have more content, you can use filter, you can select how many number of rows you want to see and the numbers of entries. So this is how to investigate a database table. So investigating means that you want to know what are the fields that you have inside this table, so that when you want to select, you know what you are selecting, right? So these are the two tables that we'll use, the flight connection table and the carrier connection, then the flight carrier database. So if you look at it carefully, the flight carrier database has the carrier name, while the flight connection table does not have the carrier name. So that means if you want to show both the departure airports and then the name of the airline, then we have to combine these two tables together, and that's where CDS view comes into the game, which is called data services. So instead of just using join, you can actually use CDS view to combine these two tables together and then pick the fields you want to pick. So I already said this in the explanation, what it means to investigate a table. It means that you identify the keys. So these are the primary keys. You understand the field types. You understand if it's client dependent, and then you understand from the table which fields you need to select. So CDS view are actually very important because, like I said during my explanation, that when you are reading from tables directly, it works. But in modern ABAP, SAP actually prefers that we expose data through CDS views. And this is because it gives cleaner names. So you can give alias names to the fields, and then you can also have reusable logics. It also gives relationships through associations, and finally it becomes the foundation for RAP and Fiori. So we're going to see how a CDS entity is created. So the CDS entity that we're going to create is ZI underscore flight underscore connection, and the description is flight connection with airline name, so with association, and these are the fields. All right, so I'm going to open the code now and I'm going to show you what this means. So to define a CDS view, use the keyword define and then view entity. You give the name for the CDS view that you want to create, and then as select from. So this is the table we are selecting from. So Z flight underscore connection. So if you click on F3, it will take you to the definition of the Z flight. So this is our Z flight table, right? The main data source is this Z flight underscore connection, and then we give an alias con. So this is our connection table. Then we define an association. So this association to another table, and the 0 to 1 means that for each connection there is a 0 or 1 carrier record. Okay, and then this underscore carrier is the name of the association. All right. So very important is that the association is like saying this connection belongs to an airline and you can navigate to the airline. All right. So we also have fields that we define inside the CDS. So we expose fields with business friendly aliases. So now this connection.carrier ID, because our connection now is the alias for the Z flight connection table. And remember that inside the Z flight connection table, we have carrier ID. So it's a key con, which is the alias, dot carrier ID. So it means go to this database table, access the carrier ID and change the alias, or use this alias instead as airline ID. So instead of just showing carrier ID, you are going to display airline ID. And then the second key, connection con.connection ID as connection ID, and then you give subsequent aliases, and at the end you put the name of the association. Okay, so this is how to create the CDS views. And of course, if you want to see the procedure for how to create the CDS view, so you can go to the package, you can go to the package, or you can go to the package that you want the CDS view to be created inside. You can see here core data services that I have here. So just right click on the package, go to new, click on other ABAP repository. You want to create a CDS view. So what you need to do is to search for data definition. Okay. When you click on this, click on next, and then you give the name of the CDS view. So for instance, I'm going to give a different name just for demo purposes. So let's say Z_2, right? So I'll give a description and say flight connection with airline name demo, right? So click on next. We don't have a transport request yet, so we covered this in previous lessons. And then click on next. Now right here you are going to get some templates for you to use. You can keep them as it is. All right, so click on finish, and then you see we have the templates. So right here you are define root view entity. This is the name of our CDS view. As select from, you put the name of the table that you are selecting from. All right, and if you go back to this, you see that as select from, you put the name of the database table you want to select from, and then you give an alias. So I can just put it right here. And then you also replace the other template for our demo. For our CDS that we created, we did not use composition of, but we use association name, right? So this is the association. You give this association to, you give the second database you want to create the association with, you give an alias, and then this is like the foreign key primary key connection. So that is on carrier.carrier ID. So what this means is _carrier is from the table zflight_carrier1. So if I go to this table, I access carrier ID. If I go to zflight carrier 1, I access carrier ID. If I go to zflight_con, which now has the alias of con, so that means if I go to zflight con, I can access carrier ID. So this is foreign primary key relationship. So the things that these tables have in common, these two tables have in common, is what is the carrier ID. So when you are creating an association, you need to create what does the two tables have in common. So the two tables have carrier ID in common. So that's how you create your association. And then the rest of the fields, you write your fields. So con.carrier ID as airline ID, con.connection ID as connection ID, and like that. So this is how you create your CDS view and the association. So now finally we are going to the third section. So the third section is that we're going to create a global class. Okay, and this class is going to be our flights lookup program. And we need a global class because we want to display things in the console app. And that's why we are also going to implement this interface. If you already followed from lesson 1, you know that we use this interface so that our program will run on the console, so that we can use the out class to display our output. So this is the skeleton. We have class definition, the name of the class, public, final, create public, the public section. So here we already covered public means that it can be used externally. Final means that we will not inherit from it, so there's no inheritance. Create public means that it can be instantiated, so it means we can create objects with this class. And of course, the public section, we extending this interface, we implement this interface so we can run our program using F9 on the console. So let's go back to the code. So let's put a breakpoint here. All right, and then we have a breakpoint here. Okay, one thing you should also remember is that after you create all your classes, all your tables and CDS views, do not forget to activate. So I'll activate the class. So here it's activated. Then I'll activate the table rather. So database table activate. So these are global class, okay, that we are going to demo. Lesson 5, demo our flight database plus CDS. And now our Z flights carrier underscore 1, we need to put in data. We need to add content. So that's why here you see here that LT is equal to value. So this modern syntax. So data define here an internal table, and then I add the values of the content I want to add. So I'm adding 3 fields: Lufthansa, American Airlines, and Japan Airlines. So if you want to add, you can just replicate the contents. So I just made up some airlines: European Airlines, Indian Airlines, German Airlines, okay? And then likewise, this is the connections. You just add the content. Carrier ID is this, connection ID is this, the airport from and the airport to. So do this to add the contents to the Z flight underscore connection. So now after we've added the content, we need to update the database. So we use the keyword modify. So modify, and then from table, we give the name of the internal table. So the modify, what it does is that it actually inserts data if it does not exist already, so which is very helpful. And then if it exists, it will update the information. All right. So notice the add symbol. So in ABAP SQL, add means that this is an ABAP data object. So we are saying modify the Z flight carrier from table, give the internal table name, which for this one, this we define here, where we added the content for the Z flight underscore carrier underscore 1. And then this right here, we are also updating the database using the contents that we have from LT underscore connection, which are the contents for the Z flight underscore con. All right. And then finally, we're going to write to the console, sample data inserted and updated. All right. So let me put a breakpoint here. Let's save this, control save. You can do control F2, syntax check, no errors, then activate. So once we activate, we can click on this symbol to run as console application so that let's see the first output. So it opens in debugger mode. There was a breakpoint here, so I'm going to skip this. So here I double click on the internal table. So right here you can see we have Lufthansa, we have American Airlines. You can expand to see that this was added. I have Japan Airlines, European Airlines, like so. Then if you double click on this, on the other work area for the connection, you can see that they were added successfully. So on the console, you actually see this was added. All right. So on the console, you can see that we printed lesson 5, demo and flights database tables. And then you can see here sample data inserted in Z flights and Z flight connection. Okay, so the next thing we're going to do now, let me remove the breakpoint from here. So the next thing we're going to do now is to select single from the table. So now we do our first lookup using the table directly. So now we are not going to use CDS view for now, and we are going to use this code right here. Of course, you have to define some variables. So data, carrier ID, type, Z flight underscore carrier ID. We give a value of LH, Lufthansa. Then connection ID, value of 0400. The data, the departure airport from, destination airport, airport 2. We define these variables using the type. Okay, and of course we clear airport from and clear airport 2 so that we don't have any content in these variables. So now here comes the select statement. So we want to select single. Select single means we want to select one record. So it means returns only one row. And so select single, which database table are we selecting from? That's, you use a keyword from. Select single from, we are selecting from the zflight_con. And you can click on F3 to go to the definition of zflight_con. So these are the fields that are in zflight_con. So when you are selecting, this is where investigation comes into. You know that I can only select carrier ID, connection ID, airport from, airport to, and in some cases the client. So here you can see that there's no carrier name here. So you cannot say I want to select carrier name from this table. Okay, so then which fields are we selecting? We have seen that the fields, we are interested in airport from _ID and airport to ID. And when you select the fields that you are interested in, you give a where condition. So we are interested in the carrier ID and the connection ID. So you can now say where carrier ID is equal to @carrier ID. So this @carrier ID is coming from what we define here. So that means the value inside carrier ID is what? LH. So we are saying select single from this database table, give me these two fields. Based on substitute this with LH, go to the table and check where LH is, and and condition. So two of them must be met. And connection ID equals to connection ID. So connection ID is what it has this value 0400. So that means is comparing, that means to check where there's carrier ID LH and the connection ID is 0400. Then we need to give a location. That's where the into comes in. So into, now say at airport from, which we define here. So get the airport from ID and the airport to ID from this table and store it inside this variable airport from, and also store it inside this variable airport to. All right, so I hope that makes sense. The select single stores just one row. From, we define the database or the source. The fields, we only select what we need. The where condition, we filter by carrier and connection, and then the into, we store results in the variables that we declared above. Now we are going to explain the next line of code, which is when you make a request to the database, you always need to check sy sub rc. That means to say, was the query successful? Okay, so every select statement ABAP sets sy sub rc. So if we have a 0, if the value of sy sub rc after this query is equal to 0, it means that the query was successful. And if there's any other value, 1, 2, 4, 5, 6, 7, 8, 9, 10, then that means there was no data that was found. Okay, so notice that in this table we are going to now display flight, carrier ID, connection ID, airport from, and airport to. We're going to see the output now on the console, and there's an if statement, if an else statement. So if no row was found, you write, oh, no row was found for the carrier ID and the connection ID that you imputed. All right, so you can use the debugger to also play around. I will show you the output. Now look at the output here, flight LH040, and then we say it should give us the from. So you can see here, this is the carrier ID LH, this is the connection ID 040, and then the airport from, and then the airport to, from Frankfurt to München. So you can see here, airport from Frankfurt, we have this arrow mark symbol, then airport to, right? And then we printed or we displayed the context. Note table rate gives us airport but not airline name, which is what we write here. So because we do not have the airline name here, the airline name is in another table. The airline name is not inside the zflight_connection, but the airline name is inside zflight_car_1. So this is where we can get the airline name from. So what we do, this is where we use CDS views, and We already created our CDS view to contain the name of the airline. All right. So instead of selecting from the database table, we'll use the CDS view as the source. All right. So let's go to the global class. So first we'll display select single from CDS view entity zi_flight_connection. Of course, if you want to do any, we are selecting, so we create some variables. So we use data to create this variable declaration. I've already explained it. If you are following the lessons from lesson 1 to lesson 4, create data, then give the variable name, the type, we give a type. So zflight_connection-airport from ID, this is the type. And destination airport, and now we add airline name. So now we clear airport destination airline name in case there is any value that has been stored there. So here comes the select statement. We use select single as usual. We are only interested in one record. So now we are now saying from the CDS view, which is zi_flight_connection. So now the next thing we are interested in is in the fields. Select single from this CDS view, and then the fields will now be departure airport, destination airport, airline. Remember that if you go to this if you go to the CDS view table, you can click on F3. We are using aliases, see, annotation. So you can see con.carrier ID as airline ID, con.connection ID as connection ID. So instead of just saying carrier_ID, we use a more descriptive words, more descriptive variables. Okay. Alright, so these are the fields that we are selecting, or that we are interested in. Then we add the where condition. So where airline ID is equal to the carrier ID. So remember, we already gave carrier ID at the top, so which is this value LH, alright, Lufthansa, and also another condition attached, and connection ID is equal to @connection ID, which is 0400. If you click on F3, it takes you to where you defined the value for connection ID. So it checks this condition, and then after it retrieves that row, it will now store the values into departure airport, destination airport, and airline name. So since the values are stored here, we can just do whatever we want to do with the value. So we display. We use sy sub rc to check if the query was successful. So that's why we say if sy sub rc is equal to 0, which means that the query was successful, then write this to the console. So we use the outright. Remember, this is expression. So the pipe symbol, you put the literal flight, and then to pass in parameters or variables, you use the curly brackets inside the pipe symbol. And this is another variable also, connection ID inside curly brackets. Remember that if you are doing this, you must keep a space between the first curly bracket and your variable or your parameter, and like that we display. And also CDS is nicer, readable fields, we write this also on the console. So if no data was found, say no row found by CDS for carrier ID and connection ID. Okay, all right. So remember to always do Control Save, activate, check, and activate. So now you see the output here. Remember, first we display this on the screen. Select single from CDS view entity, which is what we have here on the console. And then if you scroll down, the first write statement is flight. Here, flight. Then the carrier ID is LH. The connection ID is 04. Departure airport Frankfurt. Then destination airport München, which is MUC. Now airline. Now we have airline to display airline Lufthansa. So you now see that we are able to access another field from another table using the CDS views. Alright, so the field names are actually more readable as we have seen, and now we get airline name because the CDS view includes it through the association. So CDS is a cleaner and more maintainable way to expose data because it packages the logic in the data model. It's not scattered across ABAP programs. Alright, so now let's search for a non-existing flight. So we're going to make an example. What if you entered a flight or carrier ID that is not part of the database that is not a database. So here, show empty result behavior. So here we are defining two data like bad carrier. So XX, we don't have XX in our table, and then another bad connection, we don't have 999 in our table. So then you now say, okay, another error that we're going to simulate is also we're going to intentionally not clear the partial airport. Okay, remember we always clear the variables that we are using so that there are no previous data inside. So now we are going to intentionally not clear. So first we select single from this database, the zflight_connection. We are interested in the airport from ID, where carrier ID is equal to bad carrier ID. So we are saying the carrier ID we are looking for is XXX, is XX, and then the connection ID is 9999. And then we are going to store it inside departure airports. So this departure airports, we already have it here, right? So departure airports, Frankfurt, from the previous select statement. Okay, so and we are still selecting departure airports, but we are not clearing the previous data. So let's see what happens. So if sy sub r is equal to 0, we print on the screen found departure_airport. Else, we're going to say no row found, and then we are still going to say departure airport still this because the select did not overwrite it. So of course we know that best practice is always to clear the target before select so that you handle the no result branch. All right. So you save, control save. You do Control F2, you check for syntax errors, and then you activate. So on the console, you have this no row found for sy sub rc. So no row was found because this data that we added, XX and 999 as connection ID, does not exist in our table. It does not exist inside this table. You can also inspect the table. Just go to the table, F3, and let's open the project explorer. So you can use the link to editor to know where the table is. Right click on this, open with data preview. So right here you can see that there is no XX in our carrier ID, or in the connection ID there is no 999. So this will definitely return a false select statement. So no row found because our sy sub rc is less than or greater than 0, but the departure airport is still Frankfurt because the select that we did not overwrite it. So we always need to clear. So the best practice is clear targets before select so that we handle the no result branch. And now you can use data preview like I've demonstrated on your tables and your CDS views. So let's preview the CDS view. Right click on the CDS view, open with data preview. You can see now our CDS view have airline, connection ID, departure airport, destination airport, and then the airline names. All right. So the lesson objectives are as follows. You are going to understand what a structure is, how to declare local and nested structures, how to assess structure components, how to fill the structure with modern ABAP syntax, how to avoid common mistakes when assigning structures, and also how to use corresponding safely in real projects. So we'll learn all this using a small flight connection mini project similar to what you are going to be seeing in real SAP system. So this video is in two parts. So the first part is me explaining the concept of data structure, how to work with structured data, how to assess nested components, how to use the value hash to fill in structures, and the mistakes to avoid. In the next video, and the link in the description, I will explain and show you how to create these structures in Eclipse ADT. The link is in the description. And if you like this video, please don't forget to hit the like button, subscribe, and share to someone. So for the project context, imagine we are going to build a back-end service that will handle flight connection data. So each of the flight has a departure airport, it has a destination airport, it has an airline, and optionally a system message. So we are building on the previous lesson, lesson 5. So if you're just joining, you can also look at lesson 5 to see one of the projects that we built. So the first thing we're going to see is what is a structured data object. A structure in ABAP is one variable that contains multiple components. So each component can have a name, can have its own data type. It behaves like a normal variable, but instead of managing many individual variables, we group related data into one structured object. You'll see how this works in practice. So for example, here we are defining a local structure, a local structured type. So when you want to declare a structure type, use the types keyword, and then you start with begin of, then you give a variable name, so st_connection. So this is the variable name for our structure, and then you give the fields. So this structure represents a flight connection and has 3 components. So this definition exists only inside this program, which makes it lightweight and flexible. So this is a local structure. We have airport from ID, the first component, airport to ID, carrier name, and of course if you are defining variables, you need to give a type, right? So this type is already in the training system. For SAP, you can have access to it. So we create a variable connection using the data keyword that will carry the type of structure. Remember that we use structures for reusability. And when you want to access or put values into the structure we just created, you can just say connection hyphen the component inside our structure, and then you pass in the value. So which means airport from ID will carry ABC, connection airport to ID will carry XYZ, connection carrier name will carry my airline. You will see this inside the code. Just follow carefully. So the next thing we are looking at is also nested structures. So for nested structures, similar way of defining use types. But the difference between nested structures and ordinary structures is that nested structures can also contain other structures. So for example, this message here, message type of SYMSG. SYMSG is a global structure that is in the system. Anyone can access it. And then we declare connection nested as a type of ST connection nested. And similarly, we want to access nested components. See connection nested hyphen message. So we want to access the message component, and message component has this child component. So nested message hyphen mstgy, then you pass the value. Connection nested message hyphen msgid, you pass in the value. So for nested structure, we simply change the notation. That's how it works. So this is extremely common when working with messages, documents, or business objects. Another thing we'll look at is filling structures with value, hash, then open and close curly bracket. So you can also use this value keyword to pass in values to our component inside the structure. For example, we want to pass in to our connection structure or connection variable. We want to pass in ABC to airport from ID, XYZ to airport to ID, my airline to carrier name. So values are assigned by components name, not by position. So this is actually recommended modern ABAP Cloud approach. If you want to assign, you use this value hash to assign values. Likewise, if you want to fill in a nested structure, you can also use the value hash and then the components you want to fill in. See, message is nested inside our connection.nested. So you also pass in message, value, hash, msgtye, msgid, abc, msgno123, carrier name, my airline. Alright, so this will actually show the structure hierarchy. So nested structures are filled using nested value operations. Now, one of the common pitfalls that happens, or common mistake, is you want to make connection nested to have the same structure as connection. So if you use this approach, assignment, then this is wrong. There's going to be data mismatch, okay? Because they are not 100% the same structures. Okay, so the solution to this, first we can just clear whatever we have in connection nested, and then we use the keyword corresponding hash, then passing connection. So what this does is that only matching fields names are transferred. So this is safe and professional way to assign structures. All right, so let's after this introduction, let me show you in the code how this works. So we're going to create a global class. Go to one of your packages, right click on the package and click on ABAP class, give it a name and then give it a description. Structured data objects in ABAP SQL. Let's add our interface, which will help us to display our text on the console. if_oo_adt_class run. So click on next. We are not assigning any request, any transport request. Click on finish. All right, so let's now create the st_connection structure. So st_connection structure we're going to create here. So our local structure type. So we go inside the implementation part. The structure is created using the types keyword, and then we have begin of the variable for the structure is st_connection, and then the components airport from ID, airport to ID, and carrier name, which has a type. So if you click on F3, you can see more about this data element. So this is domain. Okay, so let's go back. Afterwards, we create a structured variable that contains all these three fields. So if you want to create a variable, use the keyword data, right? And then you have our structured variable here, and then the type will reference this STY connection. So remember that we are creating structures for reusability. So if I want to create another structure that carries this component, I can just say connection 2 type st_connection. So reusability, you can always have those same structures. And so this is normal structure. So the next structure we can define is the nested structure, because in real applications, structures often contain other structures. So you can also use the keyword types. So types begin of st_connection nested, and then you pass in the components. So but now right here is another field called message. So this message is a structure because the type is a structured type. So if you click on F3, this is what we call global structures that is available in SAP. So this is a structure that can be reused. Everyone can reuse it. System structure. So when you have a structure inside the structure, then it gives you nested structure. So likewise, we can create our structure variable for the nested structures using data. We have connection nested, the type st_connection nested. So now that we have our two structures, we have connection nested and connection. So let's do simple structure access. If we want to pass data inside connection, how do we do it? I already showed you on the slides. So we use the dash operator. You write the variable name connection dash the component inside the structure. So if you go up, you see that this is the component airport from ID. Now you pass in the value equals ABC. Okay. Likewise, the second component inside ST connection is airport to ID. Connection dash airport, you pass in the value. Connection dash carrier name, you pass in the value. So each component behaves exactly like a standalone variable. So let's display the output. Control save, Control F2 to check, Control F3 to activate. Then you can just click on F8, or you can just run as ABAP application console. So right here you can see airport from ID is ABC, airport to ID is XYZ, carrier name is my airline. So this is how you work with structures. And of course, you can also use your debugger to see the content of the structures. So if you put a breakpoint here, you double click, or you right click on the line you want to put a breakpoint, click on toggle breakpoint. And if you run again, it should trigger the debugger mode. Click this button, select ABAP application console. Okay, and then the debugger is open. So in the debugger table or menu, you have variables, you have breakpoints, you see all the breakpoints in the system. Then the variable section, you see all your variables. So in debugger mode, if you hover over any variable, you will see the content. So here you can see airport from ID ABC, airport to ID XYZ, carrier name is my airline. And you can also allow it to show here. You can see all the variables that we have: connection, connection nested. You can double click it to make it at the top in the debugger menu like this. Okay, so let's click on F8 to end the program. Then you can click on the ABAP to go to the ABAP perspective. All right. So now we can as well access nested component in the same way. We can also access component inside nested structures using the dash notation, but now it's more like a chain notation. So we use the variable for our nested structure, connection underscore nested dash message. So you are pointing to message and then dash msgty, because this SYMSG global structure have components or have fields inside them. So if you click on F3, you're able to see the fields. So these are the fields. So you can pass in values for these fields. And that's what we did here. Pass E to this, pass ABC to MSGID, and 123 to MSG N0. So likewise, you can also use an outright, and then pass in connection underscore nested to display this output on the console. So let me quickly show you how to fill the structures with value hash. So we are going to do exactly this same thing in a different approach, or with a different approach. So we can clear the connection. So we'll first clear our connection and then write connection equals to value hash. So you then pass in the values to the component inside connection. So now airport from ID is equal to ABC, airport to ID is equal to XYZ, carrier name is equal to my airline. So you can see value hash here makes fill up a structure in a clean and readable way, so it's easier. So this is actually recommended for modern cloud ABAP approach. Likewise, if I want to do for the nested one is even better. So let's first clear connection nested, and then you now use that structure variable connection nested is equals to value hash. Then airport from ID, airport to ID, you pass in the values. Now for the nested structure inside this structure, now say message, you also use value hash to access the component inside message and then pass in the value. Then carrier name is my airline, and that's that. So let me comment this out and print it at the end. Okay, connection nested. Let me also print out connection. So let's save, Ctrl S, Ctrl F2, syntax check, Ctrl F3 to activate. Let's clear this console. And now we execute, run as ABAP application console. Click on OK. We still have the debugger, the breakpoint on, so it stopped at this line. Okay, this was the first connection. So let's hit on F5. So here we are clearing the connection. So at this point you are seeing the values, the connections still have values in them. If we do F5, go to the next line, you see here hover over connection, you see that it's empty. If you double click to see it in the debugger, see that connection structure is empty. So when you now click on F5, now you see now that connection is no longer empty, now have the values in them. Likewise, connection nested, if you hover over it at this time, is empty. Let's double click to see it here. So if you are seeing connection nested and then you expand this, you see that inside the connection nested you have another structure inside. So I think this has default values. No, not default values. The values we passed earlier, we did not clear it, so we have not yet cleared it. So let's do F5. So with F5, you'll see that the values are cleared. Okay, see even message, the nested structure inside the connection nested is empty now. So if we do F5, we see now that this is populated. If you hover over connection nested, you see the values that we passed in. ABC is now in airport from ID, XYZ now in airport to ID, and carrier name is equal to my airline. Yeah, so that's how we debugged and walked through the procedures. Let's click on F8 to end this. So you have it on the console. This is for the nested structure, output from the nested structure. So the message structure inside our nested structure still has some fields that we did not pass values to. So you can as well do that. Okay. Yeah, and remember to avoid the pitfall that we explained in previous video. And if you like this video, don't forget to subscribe. And by the end of this lesson, the objective is that you'll be able to declare complex internal tables, choose the right table type, and then fill them with data. You can also read data efficiently using index and key access. So let's get started. So the first thing we're going to do is to create our console application. So let's open Eclipse. You just go ahead and create a package. So right here, I'm creating this package. So next, and let's create a new transport request. So all Cloud Tutorial Series objects that we create will go into this transport request. Let's click on finish. So now we have this package created. So to create the console application, just like previous lessons, we'll start with a global class. So let's create a global class in this our package. So we can add this package to favorites. Just right click on it and then say add to favorite packages so you can easily access it. So inside this package, let's create a global class. Just right click on the package, go to new ABAP class. So let's call the name of our ABAP class complex iTab. Put the name right here. So we can give it description, complex tables, and say internal tables. Let's add the interface if_OOAD class run. So this allows us to run the program directly in Eclipse ADT. This one, double click, next. Yeah, we select this transport request that we created earlier, click on finish. So now we have the class definition, public, final. If you don't want inheritance, create public section. Our interface is here. We have protected section, we have private section. Then this is the class implementation that implements the interface that we added to it, right? So in the step 2, we define a structure row type. A complex internal table always starts with a structure, so there has to always be a structure, and each structure represents one row of the table. So think of this structure as maybe one flight connection record. So let's go to the Eclipse and create our structure type. So inside our implementation class run, we create the structure type, and so we are creating a structure of TY flight. So this structure has components in it. We have actually done this before, so I will not spend much time explaining this. So each component, so these are components, each component becomes a column and the structure itself becomes a row. Okay, so this is reusable and readable. So I will show you an example shortly to actually know the difference between the complex table and a simple table. So a simple internal table you can define like this using data, give a variable, then type table of I. This is integer. So this has only one unnamed column. It is just used for basic scenarios. But if you are to define a complex internal table, you say you use this data lt underscore, let's say these are variable, and then type table of TY flight connection. If you are looking at a table has columns and rows. So if you look at a structure, think of a structure like a row. So if you define an entire structure, this means this is one row. So and when you have a row, you have columns inside that row, right? So see this component as the columns for one row. Okay, so if I want to define a simple internal table, I do not need to define a structure. I can just use a data type that already exists. So data lt numbers, type table of integers. So this is a simple internal table. So this is used for basic scenarios. And if you want to define a complex internal table, you define that internal table based on a structure that you already created. Okay, so we're going to define an internal table based on this structure TY underscore flight underscore connection. This right here is your complex internal table based on the structure you define. This right here is your simple internal structure based on existing data type. So when we are talking of internal tables generally, there are also different types of internal table. You have the standard table, you also have the sorted table, and you have the hashed table. So if you want to define a standard table, you can just say data, the variable name, then type standard table of your structure. You have to add standard, of course, with non-unique default key. So let's look at it in Eclipse. So we're looking at now the internal table types, and the first internal table type is the standard table. So to define a standard table, the keyword type standard table of should be there. So you have data, define the variable name, then say type, standard table of, give the name of the structure with non-unique default key. So this means that there is no automatic sorting. Okay, so if you use standard table, there is no sorting. Then you also have fast index access, and there's also slow key access on large tables. So when you use this, then you have slow key access on large tables. By default, if you use type table of, it uses standard internal table. Okay, then the second type of table is a sorted table, and to define the sorted table, you have to have sorted in the definition or in the declaration. So you have data, the variable name, you have data lt underscore sorted, then type sorted table of, give the name of the structure with non-unique key from airports, then to underscore airports. So what this means is it's always sorted by key. So this is a sorted table. You sort it by key. And when you do sorted table, you have faster key access than standard tables. So you can easily access the table, and insert position is automatically calculated. Okay. Then the third one is the hashed table. So it has to have hashed in the declaration. So data lt hashed type hashed table of t1 underscore flight connection with non-unique key. With unique key rather, airline ID, flight number. These are components from our structure. So what this gives is you have faster key access, and when you use this, no duplicate is allowed and no index access. So index is invalid. You don't use index here. Let's go ahead now and look at how to define a local table type. So a local table type means that instead of just repeating long table definition, we can just define a named table type. Okay, so if you want to define the table type, use the keyword types and then give the name that you want to give the name for that table, TT. That if you see TT, it means table type. Then you have flight. Then the type will be, let's say we want to create a sorted table type. Let's use sorted table of, and then give the structure name T1 underscore flight underscore con, and then you can say with unique key, airline ID, flight ID. So it will be sorted based on this unique key. And so to define, so for reusability, you can just say that data lt underscore connection type tt underscore flight connection. So you can just reuse this table type whenever you want to define this structure. And so we'll move further to explain what a work area is, right? So for complex table, the work area must be structured. So the best practice is to use like line of. So to define the work area is a data ls underscore connection. These are work area, and then you use like line of lt underscore connections. So it will take the structure that it will define in the table type. And so if you want to fill the work area and append, you give the work area name and use hyphen and then fill in the component. Likewise here, see if I do ls underscore connection. So if you put hyphen, it gives you the columns that we have or the components. So if I want to add airline name, just double click on this and say equal to, so flight number, let's say 0400, put a period. You can likewise do ls connection. If you put hyphen again, it gives you the component. So here will be flight number, double click, equal to, let's say France. So I'll just fill up the other ones. Okay, so we have 2 airports and airline name. So after we fill the work area, what we need to do, we need to append to our table type lt connection. So use the keyword append the work area ls underscore connection. Use the keyword to our table type lt underscore connection. All right, when you save this, if we use the debugger to inspect the table, to use the debugger, you can just highlight or double click on the line. So you can see that I've made a toggle. You can just right click and say toggle breakpoint. You add a breakpoint to this line. So, and then you can just execute. It should trigger the debugger about application console. Yeah, before then it did not trigger because we did not save. So let's save and activate. Ctrl S, Ctrl F2, no errors, Ctrl F3. So let's activate and run again. So now you have the debugger, right? So you can view the content of the LT connections. You can, if I click on F5, this is LS connection. This is the content in LS connection, and this is LT connections, our table type. So when you double click, you see the data in the table. So you see that the structure is a row and the components are the columns for that row, all right? So you can play around the debugger to see the content of the work area and also for the table. So this is how to work with simple internal table structure and complex internal table structure, and you can also play around. Of course, there are also ways you can fill up your work area and append. Let's just click on F8 to end the debugger section. Then you can click right here to go back to the ABAP perspective. Alright, so another modern way that ABAP allows us to append rows without using work area. So if we don't want to create this work area, you can just use the value. So let me comment out this. Comment this out. So when you use append value, then write the name of the structure. So append the values to this structure and then just give the component airline_ID, AF, flight number, from airports to airports, airline_name to this table. LT connection is our table. So we are appending these values based on this structure to this table, and this table is a table type. Okay, let's put a breakpoint here, double click on this line, and let's control save, check, syntax check F2. So ignore these 7 errors you are seeing for now. I'm working on another project and there were some errors there I needed to fix. But for this particular example, there are no errors. So Ctrl F3 activate and let's run to trigger the debugger. So in debugger mode, in debugger mode, you can double click on our table, LT_connection. So when you double click, you get the table data down here. So if I drag this up, see that the contents have been appended or added to it without using a work area. So this modern way of how you can append. So you can also see the content right here on the right, LT_connection table. We have airline ID, flight number from airport. So if you want to add another row, you can just use the append without creating a work area. And so you can see append value, TY_structure. So let's just change this one to AS 1021 CDF JFKE. Can just say Emarok. Alright, so let's save this. Let's check, activate. Let's execute this. ABAP console application. So this was the first row. So let's do F6. So F6 takes us to the second row that I want to add. So let's do F6 again. So if we check the table, LT connection table, double click on this. You now see the content, first row, second row, double click and you take it up. You now see that I have 2 rows to the table. So these are how you can add rows to your table without using the work area in modern ABAP. So this one, your code is shorter, less memory usage, and is preferred for modern ABAP programming. Okay, so another way to fill up the table, we can just click F8 now to exit the debugger and select here to go back to the ABAP perspective. So let me comment out this. So you can actually fill up the entire table at once. Fill up the entire table at once. Okay, and how can you do that? You can use the value hash to fill up the table. So you see here, I call the name of the table LT_connection, use the value hash, and then write the components or the columns for each row. So airline ID equals to LH, flight number, then from airports to airports, the value, airline name, the value. And so each row is in a bracket. And then the second row, you can also add a third row by just copying the components or the columns and changing the values. LA, say 3, ZHR, AFK, can just say in Indian Airways. The disadvantage of, or one thing you should take note about using this is the existing entries are deleted. So if there are entries that exist, they'll be deleted and the new entries will be added. And secondly, the tables are always rebuilt from scratch. So whenever I use this value hash, the tables are rebuilt from scratch, unlike the other tables that you can keep appending or keep removing. All right, so another thing we should also do here is how to copy data with corresponding. We have also done this before. So if you want to copy data, we use the corresponding keyword, and here we are defining our table type, our table. So data LT carriers, table type DMO underscore carrier. So this, if you click on F3, so this is a table that's already been defined. Flight reference scenario carrier. So we can use the table to define or give a structure to LT carriers. Okay. And then we can say LT connection is equal to corresponding LT carriers. So it will copy only identical named fields and extra fields are ignored. So it's only the fields that are identical to LT connections that will be copied. All right. And we've done this also in the previous video. You can also see an example of this. And next is how to read data from complex tables. So to read data from complex table, you can use the keyword read, to read only one record. So you can say read table, you give the table name, LT underscore connection, index 1 into LS connection. So you are saying the first index, read it into LS connection. So it will retrieve the first row of the table into LS connection. And this is very fast and works only with standard table and sorted tables. So you can also use key access. Okay, you can also read data using key access. So you can play around with this, read the data, debug in the debugger mode. So using key access, we can say read this table with key, airline ID and flight number. So this is going to be our key that is going to be using, and into this work area, LS connection. Performance will depend on the table type and is best with sorted or hashed table. So in summary, the complex internal tables are the backbone of real ABAP applications, and once you understand how to declare, fill and access them properly, you are already writing production ready ABAP. So if you like this video, please hit the thumbs up and subscribe. See you in the next video.
Business objects, behavior definitions, behavior implementation, entity manipulation language. So the entity manipulation language, if there's still time, we'll go into it. Otherwise, we'll look at it in the next video. So by the end of this lesson, you understand what a business object really is, how to analyze a business object, how projections and interfaces work, and how to modify data using entity manipulation language in the ABAP Cloud. So this will be in the next video. So as part of the modern ABAP programming, you will have to come across business objects. So what is a business object? Now, in ABAP Cloud, we no longer just think in terms of tables or select statements or update statements. So instead, we talk in terms of business objects. And a business object actually represents something that is real in business. For example, we can see a travel agency, or an example also can be a sales order, or an example can also be a customer. Another example is a purchase order. So it is not just a table like we know. So there are three things involved. It is data, behavior, and rules. So whenever I think of business object, it involves three things: data, behavior, and rules. Now, a business object actually has two main parts. The first part is what we call the data definition, which is CDS view, core data services views. And what this does is that the view defines what field exists. It also defines what the structure will look like, and it defines also what the keys will be. So for example, if you have a view, you can have fields like agency ID, the name, the street, and the country code. And when you talk about business object, the second part is behavior definition. Now, when you talk about behavior definition, this defines what you can do with the object. Okay, so you've defined a view, CDS view, for the business object. So what can the business object do? This is what the behavior is all about. So can you create, can you update, or can you delete? So these are the things that the behavior definition will be responsible for: to create, to update, to delete. Likewise, the business definition also involves validations. Will there be validations, determinations, and actions? Okay. Now, this is where business logic rules are defined. So the behavior definition basically is where we define the rules that governs our business logic. So to understand further what a business object is, this tutorial is more about project-based tutorial. So we are going to be building our own business object from scratch. So what we will do is that we are going to create a CDS view, then we are going to create a business object, a behavior definition, a behavior implementation, and also finally we manipulate it using entity manipulation language. So if you want to understand the wrap and modern ABAP Cloud. So this lesson is very important. And the first step we're going to do is we're going to create a database table, the table that we are going to be using for this demo. And let's imagine that we are building a simple product management system. So let's go to Eclipse. So in Eclipse, I will just select my package, and then I create a table. So we are creating a database table. So right click, new ABAP repository object. You can just see database, and database table comes up. You click on database, click on next. So let's give it the name SAPVIC products. So we'll create a transparent table for this our product management system. Description, product table, click on next. And then we have the key clients, and we can enter the fields for the table. So these are the fields for the table: product ID, name, price, currency, created by, system username, created at, the timestamp. So because it's better to use data elements defined, but I'm using built-in data types here. All right. So let's save and activate our table. So let's just see maintenance allowed here. Let's change here to allowed so that we can do maintenance on the table. So this is a transparent table, and then you can see the description here, product table type, product table. So let's save, Ctrl S, then Ctrl F2, syntax error check, then we activate, Ctrl F3. All right, so our table is activated, but remember that in ABAP Cloud, we don't access tables directly. Okay, so now you have a table you do not have to access it directly. So that is where business object comes into the game. So we are going to now build business objects. And before you actually build a business object, you need to have a root CDS view. We've covered CDS views in the previous video in lesson 5. So if you are new to this channel, please go ahead and watch the lessons. Lesson 5, we also covered CDS view in that lesson 5. So, and like I explained initially, a business object has what? 2 parts. We have the CDS views. So that's why we need to create a CDS view, and then we also have the behavior definition. So now let's go ahead to create our CDS view called data service that is related to the table we just created. So let's go to Eclipse. So what you can do is you can right click on your package and then go to new. You can, or rather, we look for data definition. So click on data definition, click on next. So we are creating a data definition. So let's give it the name SAPVIC. So we can see, so we can give the name SAPVIC, our products, core data services for products. Let's click on next. So normally you select a transport request for this, but we are working with free version on the cloud, so we don't have access to create this transport request. But in real application, you'll need to create a transport request. You click on this and create a new request. So here we just click on finish. So now, so you see define view entity for SAPVIC, our products. So select from data source. So here you are going to write the name of the database table that you are selecting from as a source. So the name of our table was what? SAPVIC underscore product. So let's copy it and paste it here. All right. So now the next thing we need to do is to fill in the fields that I want to see from the view, or that I want to see on the view. So let's copy this, copy and paste this right here. All right. So in the view, we have this error here. Okay. And the error is because it's related to the currency reference for the price field. Okay, so now we need to properly annotate the price. So it says semantics.amount.currency code currency. All right, so that means my price is pointing to the currency, to the units of measurements. So if you are dealing with maybe things like weight, then you also need to point to the unit of measurement. So one more thing, let's add the key here. So that's how we're getting error below. So it's a key product ID. So once again, what did we just do here? We defined the structure of our business object. So this is the definition part, but right now it is just data. Remember that we also need to define the behavior and also need to define the rules and also the logic. Okay, so the next step is now to create the behavior definition. So behavior definition will define what the business object can do. Can you create with the business object? Can you update? Can you delete? Are there validations? Are there determinations? And are there actions? I'll also explain this as we proceed in the video. So now the interesting part, so let's right click on our package. So I'm using this package here. Let's right click and let's go to new, other ABAP repository objects. So let's search for behavior definition. So it's typing core data services, then under that you select the behavior definition. So let's click on next, give a description for it. So we are doing for, let's say, behavior definition, behavior for products, and the root entity will point to our CDS view that we just created as our root entity. Okay, so these are root entity Z our products. So let's go back and activate. So let's syntax check and then activate this. So let me also activate the table. Now let's create it again. Behavior definition. Click on next. So root entity. Let's search for it again. Now it appears. So we now select the CDS view that we created, and now you have implementation type. You can see managed and unmanaged. So we'll look at this also. Look at the explanation of this in the next slides. But now let's just create managed. So alright, so let's click on next. Alright, then we get an error here. SAPVIC_R product is not a root entity, and the reason for this error is because we need to specify root in the definition. So let's go back to our CDS view. So right here we need to indicate that this is going to be the root entity. So just type in root here and let's control save again, syntax check, and then activate. So this is activated. One more time, let's create the behavior definition. So let's click. So select behavior definition next. So behavior for product. Now select the root entity SAPVIC_R_products. Click on OK. So now we can proceed. Click on next. Click on finish. So because selected managed implementation, you see managed here. This is the class name. We also have authorizations, create, update, delete, and the field. Now let's understand the behavior definition. So let's simplify this object we created now. So when you open any behavior definition, you will see something like define behavior, right? And then behavior for this root view, which is our CDS view, and of course we need to give an alias name. So the alias name is very important because when using entity manipulation language later, you must use the alias name to access the entity. So let's give an alias name. So now inside the behavior definition, you will see something like this: create, update, delete, specify the fields or the field. So this means that the object will allow this operation. The business object will allow you to create, to update, and to delete. So if you try to update without update being allowed, you'll get a syntax error. There's also validation checks. Okay, so in the business object, there will also be validation checks, and validation check if data is correct. For example, email must be valid, name must not be empty, country code must exist. So you define validations in the behavior definition. So, but you implement them in the behavior implementation class. Okay. There's also determinations. So these automatically change values. For example, automatically calculate total price or automatically set the status of a field. And there are also actions. Okay. Actions are like special operations. These are not the create, update, or delete. So these are special operations. For instance, you want to approve purchase order, or if you are using a flight agency system, you want to cancel flight. So these are actions. Confirm booking. These are actions. So all these, you can define them in what? The business behavior. So these are business specific behaviors. After you have defined the business behaviors, you also need to define what we call behavior implementation. So there are two implementation types. The first one is the managed implementation type. Okay. So like you see when we're creating, you see the option to either select managed or unmanaged implementation. So for the managed implementation, the system will automatically handle the create, the update, and the delete. So you only need to implement the custom logic for validations. So this is even the modern recommended approach. While the unmanaged implementation, you must implement everything manually. So it's more complex, it's used in advanced cases, and the implementation is also done inside a special class called behavior pool. All right. So let's go back to so let's add validation to our behavior. So you can just say validation. So the name or the variable validate price on save. So whenever I save, create or update, then it needs to validate the price. So this is how to add validation. We have added validation. So I'll open another project and show you determinations and actions. So this is a behavior definition for a flight agency. So you can see here we have use create, use updates, use delete, and also you see here that there are actions here: use action resume, use action edit, use action activate, use action discard, use action prepare. So these are all actions that you define in the behavior. Now you can also see this another managed implementation. So another behavior. So right here you can see the create, update, and delete. These are the fields of interest. These are the actions: resume, edit, activate, discard. Now for validations, you can see that the added validations here. Validations, we give the validation upon save, then validation. So right here we also create our own validation. So in a nutshell, what we are doing in our business object behavior definition is that our objects we allow our objects to create, to update, and to delete. So now we can also say that the fields that will be read-only, the fields that will not allow create, updates, and delete. Product ID, you cannot create product ID. You can also add other fields. So let's add created by as read-only because you don't want someone to edit or update this. So this should be automatically created by the system, or you can only read it. And also the time at which it was created should only be read-only fields. All right. So, and then we have this validation, validate price. That means whenever someone creates or updates, so create or updates, the price must pass a rule. So there must be a rule that must be passed. But where do we write that rule? That's the next important question. And that rule will be inside the behavior implementation class. So we need to create a behavior implementation class. You see that ADT already automatically created that for us, but it does not yet exist. So we can create it. Let's see if we do control exclamation mark, then create behavior implementation class, double click on this. The open behavior definition is not active and unlocked. So create behavior information. The behavior definition has to be active. Okay, so let's save this. Let's save the behavior definition, check for syntax error, no errors found, activate this, Control F3. So since it's activated, we can go ahead to create the implementation for our behavior definition. So let's just control exclamation mark to give us a help functionality. So double click on this, and now we have this pop-up to create a new behavior class implementation. So yeah, let's click on next, click on finish. So what we are creating now is called the behavior pool. Okay, now we are inside the behavior pool. Let me minimize this. All right, so inside it you also see a local class. So right here, this is a local class, LHC_products, and now we need to implement the validation method. Remember, we created in validate price in our behavior definition. So these methods comes automatically, leave them as they are. So now when we go to the local class inside the behavior pool class, you can see the method here that we need to implement. We need to implement the validate price. So here you can just write the functionality of how you need to validate the price. Okay, I'm getting some intelligence here. So I'll leave the validate price method code in the comment section so that you can easily copy and paste it in your code. Basically what the code is doing, that if you have a product table and you want to make sure that when you save, no one should save a product with a price of 0 or less. So that's where we create an error here. Price must be greater than 0 if price is less than or equal to 0. Okay, so basically the first part here, read relevant product instances. What's happening here is that we are asking SAP to read product information from our database. So read entities from this our table, and the entity has this alias products. Remember that we gave the alias name products to this our table. And then which fields are we interested in? We are interested in the price field. So if you want more fields, you can add, but since we are saying validate price, we don't want any other column, right? Then with corresponding keys. So the keys tells us which specific products we need to check. And then the results will be stored inside this internal table, LTO_products. So result is a keyword. And then if anything goes wrong with the reading, that information will go to ls_read_field. All right. You use this keyword field and then you define the internal table. So this is where the validation goes. This is where the checks takes place. So if the price is less than 0, output this message, price must be greater than 0. So this method will run automatically during save, because we said the validate should run upon save. If we go to validate price on save, so that method will run automatically when we save. So if price is 0 or negative, the system will throw an error. And this is actually modern ABAP Cloud validation. There's no need for manual commit, no manual checking outside, and the framework will handles it. So let's save and activate. Ctrl S to syntax check, Ctrl F2, and then Ctrl F3 to activate. So now another important thing that we need to take note of is the concept of business object projection and business object interface. Okay, so business object projection, you should never directly access a business object. Okay, so we have created our business object, we've created the behavior, we have created the implementation, but do not access it directly, and that is why we need to use business object projection and business object interface. So for projection, that's for the UI services, and for interface, that is for ABAP coding. So business object projection is actually used by Fiori apps and OData services to consume your business object behavior, and then it defines what fields are exposed and what operations are allowed. For the business object interface, this we use it inside the ABAP code, and also is used by the entity manipulation language, and it provides stable access and released API-like access. Okay, so what we need to do now is that we are going to create an interface, business object interface. We need to create a new data definition. So let's right click on this, go to our other ABAP repository, data definition, click on next, and then we give it SAPVIC_I. This will stand for interface, and just say product interface. So referenced object, on reference object, let's select our database table. So let's select this, click on next. So let's select define view entity, then we'll make adjustments to the code, finish. So right here, define, we're going to say define roots view entity. This is the name of the interface we are trying to create. So inside the interface that we are creating, say define root view entity SAPVIC_I_product. So now we have the provider, contracts, then transactional_interface. So this is what the business object projection is using. So as projection on our database table, all right, and these are the fields: key field, primary key, product ID, name, price, currency, created at. Okay, so when you see provider, contracts, transactional_interface, this is referring to the ABAP, okay, the ABAP interface, that is the business object interface. So there's another one. If you see provider, contract _transactional query, then that refers to the business object projection. Okay, so but right here we are using the interface, so we can remove this. Okay, so when writing ABAP code, always use business object interface. All right, so let's save, Ctrl S rather, and Ctrl F2 syntax check, Ctrl F3 to activate. So now we have the interface created. Next thing we need to do is to create behavior definition for the interface. Okay, now so let's create the behavior definition for the interface. You can just go to your core data services, you see behavior definitions, just right click here, new behavior definition. All right, so the description, you can just say the product interface, then click on next. So our root entity will now be our interface that we created. Now this time around it's not our table, so we're going to use the interface, this one, SAPVIC_I_product. Select OK, then next. and finish. So you see here projection. So I will just edit it and just add interface at the top. So just give an alias. Let's say products, I_products to be interface for the products. So Control S and let's F2 and then activate. So now this is our released API. So if tomorrow we change the internal business projection, the interface remains stable, and this is enterprise level design. So now, before we go on to the next part, which is like the final part, entity manipulation language, let's add some data into our table. So our table is SAPVIC product. So if you go here, so database tables SAPVIC product. So if you check data preview, right click on this and open with data preview. So you will see all the columns. We have client, product ID, name, price, currency, created by, and created at. So but they are all empty, there's nothing inside. So we just set it up for testing. So we are not using entity manipulation language yet, so we can use entity manipulation language also to update or to insert information in our table. So for now, let's just do the normal way, test it. Yeah, so let's create a new class. Let's say ABAP class package, right click, create a new ABAP class. So insert data to the products table, internal table, create a work area, then just pass in your data to the work area. If you are not familiar with this, you can go to lesson 7 and check it out. So just Control save this. If you need the code for this, also just leave a comment in the comment section and I'll just paste it to you there. So Control activate, Control F3 rather. So we need to execute. So on the console, there's a test data inserted successfully. So if you right click on the table, SAPVIC_products, let's go to open with data preview. Then you see that we have contents in the table, right? So this is our table. We have added things here, but in modern ABAP we do not want to access the table directly. So if we want to make changes, then we can also use the entity manipulation language.
So entity manipulation language is the modern way to read and change data in ABAP RESTful application programming model, which is commonly known as RAP. So in this lesson, we are going to create a customer return request application, and we'll build a RESTful ABAP application that is going to manage customer return requests. And so this business object is going to be able to create return requests, read return requests, update return request, delete return request, validate business rules, autofill fields with determinations, add value helps for better user interface. And of course, if you are new to this channel, please consider subscribing, hit the like button, and share this video. If you don't know what the business object is, in the previous lesson 8, we also gave extensive explanation of business objects. So the link will be in the description, and you can also watch the business objects video. So the lesson agenda for lesson 9 is also in six steps. The first is database table design. Of course, if you're already familiar, you've been following from lesson 1 to lesson 8, you should be familiar with how to create a database table using Eclipse ADT already. So, but I will also show you how to create this if you are new to this channel. And we're going to create sub package and sample data for the table that we created in the first step. And then the third step, we are going to use the object generator wizard. So this will actually generate CDS entities, the CDS behavior, service definition and binding. And we're going to publish and preview our application. So that means we're going to activate the service, preview the Fiori element app, and the fifth step is that we will add the ABAP logic, which is the entity manipulation language. And right here we handle validations, determinations, entity manipulation language, read and modify entities. And finally, we have to also work on improving the user interface. So we're going to improve the field layout and going to set some fields to be read only, and also add value help annotations. Okay, so if you're happy to follow me in these lessons, give me a like and like this video so that YouTube can also recommend this video to as many persons who want to learn the modern ABAP. All right. So the first step is the database table design. And for every ABAP RESTful application, it starts with a database table. And this is where your data ultimately lives. This is where your data resides. So for our customer return request application, we are going to create a table called Z return request. You're going to see it. And now, so there's actually one important thing that we should also consider is that in the RESTful application program model, we actually work with two tables, not just one. And so the first table is also called the active table. So there are two tables, the active and the drafts table. All right. So on the left hand side here, you can see the active table. So the Z return request table that we are going to create, it stores confirmed and saved data that has been fully committed by the user. So while the second table, which is going to be the draft table, so it's going to be, maybe we'll add a D to the name to differentiate the name. And this stores in progress work. So for instance, imagine when the user is working and then it's time for break, so he needs to leave. So those work that are in progress will be stored in the draft table. Now you see the naming convention here, Z return request will be our main table, the active table. Then the Z return request underscore D will be the draft table. So the purpose that it will enable draft enabled transactions so that users can save partial data without committing to the database. All right. So this is the content of our active data, active table. So you see here we have client, which is the primary key, and then we have another UUID here. So this ID is automatically generated by the system. So if you use this data type SYSUUID underscore X16. So you get internally generated number. And then these are the other fields. So already this we've explained in previous lessons. So this is customer ID field, order ID field, return reason ID, return status, return date, refund amount, currency, and then we have data type, built-in data types we are using here, character, currency. Okay. However, it's better to use your own defined data element. We covered this in one of the lessons also. Create your own data element and then use it here. Okay. So now let's go to Eclipse and create the database table. So there are basically 6 steps of how to create your table in Eclipse. Open Eclipse, edit, set your table parameters, define your key fields, add business fields, add the admin fields, and then you activate. So I'll open Eclipse now. Of course, we need to create a package. All right, so let's say you have created your package, and then the next step, or the first step we're going to do now, is to create a database. So our database, we're going to create a table called return request table, and with table fields, keys. All right. And this table will contain all the customer requests. Yeah. So this will not work for your local server or your local system. So you need to be connected to a cloud project. And this is a package I already created inside my cloud project. Right. So if I click on F5 to see the full content, so I want to create a database table, and for that, I just need to right click on my package, go to new and select other repository ABAP package, type database. So database table comes out next. So let's give the name of the database table. So I call it Z return request and put it as 2. Give a description. So let's say customer returns request table. So let's click on next. No transport request. Say training system. So let's click on finish. And so yeah, we have our database table created, return requests, and of course the first thing you have is your client ID. You have an ABAP.client here, not null. I've also covered it in our lessons. If you have not been following, you can check out our lessons from lesson 1 to lesson 8. So now we're going to fill in with the other fields of the table. So we see the first field, which is the client field with the data type ABAP.client. And not null means this is mandatory. Okay. And then we see that this is a transparent table. And so every transparent table in SAP must start with the client field. Client field is mandatory. And the second field is the return UUID. So it's going to generate a 16-bit number for us. So this is a unique identifier, and this is like a simulation of what you have in SAP CRM, the GUID, the global unique identifier. So the great thing about using this data element is that ABAP runtime automatically assigns the UUID when a new record is created. So no sequence numbers, no manual ID management. Very important. We have a customer ID with character, data type with 10. So it's also recommended to use data element here. You can create your own data elements and use them right here. When we want to, optimize the code, we can do this later. All right. Then come our business fields, we have the order ID, the reason for the return status, okay, uses 2-character code. That's why we have 2 here. For instance, OP means open, and PR means processing, and CL means closed. So then we also have the return date. Okay, now refund amount, you need to specify the amount currency code semantics this way. So that means you are saying the currency here is what you use for the amount. All right. Now the final point is this one here. These are called the administrative fields. This right here, you have local created by, created at, last changed by, last changed at. Okay, and what this is doing here is that you're going to know who created this record, when, and this record was created by, at what time, when was it last changed by who, and what time was it changed. All right, so these fields are actually used for what we call e-tag, which is based on concurrency control. All right. So let's save this. Let's Control S. You can also do Control F2 for ABAP syntax check, Control F3 to activate. So if I right click, yeah, since this is a cloud project and it's a training ground, I'm not able to even open it with a graphical user interface, but I have it also in my on-premise system. So if I open the project on my on-premise system, I'll be able to open the table also using the SAP GUI. So let me go to my on-premise system. So I have the same table here. So if I open it, okay, this is the same table inside my on-premise system. And if you right click here, you go to open with, you can see right here, open with SAP GUI. So when I click on it, it's going to open the table for me. You can see. So this is exactly what you do when you use the SAP GUI, graphical user interface. So you can see your fields, and this is what you are actually used to before. You can see the currency is being maintained here. Right. All right. So let's go back to the cloud project. Let me minimize this. All right. So right here, we have created our table. We have activated it. And then what we need to do next is I'm going to create a class. We're going to write an ABAP class that will insert data to this our table, because if you right click and then you say open with that data preview to see the content of the table, you see that the content of the table is empty. We don't have any data in our table, right? So we don't want to fill it with data. We want to fill it with values for return, customer ID, order ID. So let's create a class. We already covered it in our lessons, also between lesson 1 to 10 to 8. So have a look on one of the lessons that we covered, how to fill in, how to create classes actually. All right, so to create a class, so this is my package. I can just right click on this and say go to new, go to ABAP class, and then I'm going to name this class zfill return underscore data. So this will fill the table with return data. Okay. So of course, if you are creating this kind of class that you want to see output on your console, you need to implement this interface if00 underscore adt underscore class run. So let's click on OK. Click on next. So it's a training system. We don't have a transport request. Click on finish. All right. So now you see that we have our class, public, final, create, interfaces, the implementation of the class. So right here inside this method, this interface method that we are extending, if00adt underscore classroom. Classroom is where we will write our code, the code that will implement, or the code that will add data to our table, our database table that we created. All right. So now this is our class field return data, and we just write this code. This we already covered it in one of the lessons, how to fill your database tables with values. So we are using the value keyword here, and then these are fields. Then we're passing the value for that field. So now the request date, interestingly, is giving this error. Say the old variant of SY datum should not be used in current ABAP language version. So this actually modem ABAP, so it's giving us a warning that we should not use this. So we're going to correct this. Interestingly, I did this project in the on-premise server and this was accepted. So this is one of the reasons why modern ABAP is interesting, right? So let's fix this error. Yeah, so for that, we are going to use this class cl_abap_context_info. Then use this method get_system_date, more like a class method, static method. You don't need to define an object to use this. And then LV user cl_abap_context_info, get user technical name. So this is what we are going to use to get our date. And so in our request date, we use LV_today, which will get today's date instead of using SY datum, okay? Then request date, we just say today's date -2, another one, today's date -5, today's date -1, and today's date -3. And that is how we work with the modern data instead of using SY datum, okay? All right, so let's save our table, Control save, Control F2 to do syntax check. There are no errors found, and then Control F3 to activate. And now when we execute as ABAP application console, click on OK. You see that in the console, we get sample return request created successfully. Okay. So if we go to our table and then you can just right click anywhere and say open with data preview, we should see the contents has been updated. So you see our clients here, we see this return UUID, unique identifier, the customer ID, just some sample data that we added, the order ID, the products ID, the return reason. So DF means defected, WRO means wrong, DAM means damaged, all right? So these are the return reasons, and you can see the quantity, the return status, 01 for open, 02. Yeah, so I updated the return status to carry the right description. So OP is for open and CL is for closed, the return status of a request closed. So if we save this, Control S, Control F3 to activate. Now you have to execute it. So let's execute ABAP application console. Okay, so sample requests created successfully. So now let's go to our database table one more time. Right click on this, open with data preview is refreshing. Yeah, so now you see quantity, return status, open, processing, open, CL closed. All right, and of course this return reason DFE means defective item, wrong item, damaged item. So our table is set. Now we see the amount, refund amount, local created by, and then created at. All this will update when I make changes. So it will show my username that I created this and when and what I changed in the database, okay? So yeah, so our database is set. So let's see what is the second thing that we need to do. Now we've done the creating table in Eclipse editing. We've done all these 6 steps. So this is the table definition, return requests, and then you define the fields. You add you add a unique ID key and E tag fields, which is these administrative fields. And then optionally, which I also recommend, you create your custom data element. Yeah, for the second step, we need to create a sub package. Okay, a sub package so that we'll have all our business objects that we are going to create. We'll put all the business objects inside that sub package. So let's go to Eclipse. So somehow I've not been able to create another sub package inside my package. I wonder why that is, but let's try that again. So this is my package. I want to create a sub package. Let's say new ABAP package. So let's call it Z. So the description will be objects for OData UI service. Then I'll click on next. So it's not allowing me to create a sub package. So the training system is not allowing me to create a sub package. I don't know why that is so. Then let's skip the sub package part. But if you are using your own system, you'll be able to create a sub package. So the reason why you're creating a sub package is that all the business objects, business definition, class definition, and class implementation will go to these sub packages. All right, so because it's not allowing us to create a sub package, what we need to do next now is that we are going to the step 3, which is the object generator wizard. So what this does is, so we have our database table already, and so elements, Fiori element application, they need a lot more object than just a table. So we need things like CDS views, we need behavior definitions, we need implementation class, we need service definition, we need service binding. And so these things, the object generator wizard will do it for us automatically. So it will create everything for us. And once it's done, we have a full functioning app that will create, that will read, that will update, and that will delete. Okay, so no ABAP code is written yet. All right, so let me show you. So the object generator wizard will generate in total 8 objects. All right, so how do we do it? We have the CDS view entity, behavior pool, project view, service definition, behavior definition, draft table, metadata extension, and the service binding. These are the objects that the object generator is going to create for us. So now how do we do it? To go to Eclipse. So in Eclipse, right click on your table. So where is my table? This is a table that we are working with. Z return requests to. So if you right click on it, you have the option generate ABAP repository objects. So when you click on this, then you're going to be asked to select from this. So first is ABAP RESTful application programming model, OData UI5 service, OData web API service. So what we are developing is an OData UI5 service. So we click on this. So you can see the details here. This generator creates all repository objects that are relevant for a business object. Let me increase it. All right. And for a wrap service. So this end result is a full-blown wrap UI service. An OData UI service makes it possible to consume a wrap service with a Fiori element UI or other UI clients. All right. So these are following objects that will be created, service binding, service definition, and all. So you'll see it shortly. All right. So when you select on OData UI service, just click on next. Okay, so it's prompting us to select a package, but I'm going to use my existing package. So the name of my existing package is, so this is the name of my existing package. So let's create on this. All right, so let's click on next. So it's saying fetching initial data. All right, so then we are faced with this. So all right, so the first thing that you see here is the object on which the root entity of the business object is based on, which is the reference object will now be our database table, which is this. This is our database table. So we'll click on data model. So this is the data model. I think for cloud, it automatically brings out the entity name for you. So if you are on a local system, you have to enter this name. So let's give it an alias. You can just say return request to. Okay, click on behavior. So it's interesting that the cloud project automatically filled it for us, our behavior implementation class. Like I said, if it was a local server or you're using your on-premise system, you have to fill this implementation class name yourself, the draft table, like I explained before. So then we can click on service projection entity. So it has created the CDS entity name, and then the service projection behavior, it has already also created a name for us. The service binding, service definition, is created a name for us also. Then the service binding. All right, so click on next. So it's generating the artifacts. So basically, so we can see what it has generated for us, the repository object. So let me show you the slide. So basically, the generator wizard will give us 8 objects. So you have the reference object, CDS entity name, business object, behavior implementation class. So if you are doing it on your own, then this is how your naming convention should be. All right, ZR for your entity name, ZBP_R for your behavior implementation class. Then your draft table should have a D at the end. For your service projection entity name, it should be ZC, all right? And the rest follows the same way. So we have service binding name. This is the example in the slide, but it's different from what we are programming. And then the binding type, we are using OData v4 for our binding type, all right? So you can also as well cross-check what we have. So you can see service definition here, service binding. Then the object type, we have the SAP object node type, SAP object type. These are all what has been created. So they are basically what I showed you on the screen, and these are the repository object that will be created. Just click on next. We don't have a transport request, so just click on finish. And yeah, so we have successfully created our business object. So the next step is what we're going to do now is to publish and then preview. So you should now look for service binding editor. So let's go to our Eclipse. Okay, so in the editor, you're going to look for your service binding. It's going to tell you service binding was created successfully. So open the service binding. So when you create that, you get this screen right here. And so here we can see add service. The service is already here. So we can say publish. So publish operation in progress. Do not modify, close or refresh the service binding. So we're going to wait. So once publishing is done, we're going to see our entity and we're going to get a browser URL. All right. So we are creating our first application. It's going to take a while, so we wait. So now you see that our entity return request, you can see right here, has been created. All right. So you can use this URL, service URL, or you can click on preview, open Fiori Element app, click on preview. It will open it in our browser. So this is it opening in our browser. We have the SAP logo here. We have our account symbol here, and it's still loading. Now you can see it coming out now. We have it. All right. Okay. So you see that we have a Fiori Element app. You can see the fields, return UID. Of course, if you had used data element, it will use the data element field that is specified here instead of these names that are not user friendly. All right. So you can see now here you can create. You can see your create button here. If you create something, you can delete. Okay. So let's click on the create button and let's see if we can create a customer request. So when you click on create, it opens another screen, right? So now we have generated core data entity. All right. So return UID is automatically created, which is what you see at the top of the screen. So let's see customer ID. So let's just look for similar type for consistency. So our customer ID is, let's see, C135. Order ID, you see right here, see draft updated. You can see that we're in the draft mode. And then order ID, let's copy one of the order and then paste, just change a few values for consistency. All right, so paste it right here. Let's say the order ID, it's 11. So product ID, so let's say here jacket. Return reason, of course, if you want to optimize the code, you can now use value help, which we'll also look at on how to do this. Return reason, create right here. So let's say wrong size, ROWRO. Then for quantity, you can just put the quantity here 2. Return status, open. So you see here request date, you can select the date. You have this because we use the current date class and not just SY datum. So today is Saturday 7th. Let's click on this. Refund amount. What do we say? 25,000. Refund amount, let's say 500. So this is the currency. You can actually select the currency. So let's use euros. See euros here, created by, created on. You see those administrative data that we added to the table, changed by. This is my ID and the date that it was changed and the time. So now that if you are done, you see that draft updated. You can say create. So you say object has been created and you see that this return ID has been created. So you can actually also edit the object that has been created, right? So let's go back. All right. So now you can click on go without entering any filter to bring all the results of the table. Click on go. So we see everything, right? These are all the data from the table. The one that we just created is this one right here. The last one this is the last one we just created, the last customer request. Just create like this. So you see the whole details. You can see edit here and you can delete here. So delete also works. So let's go back and delete an item. So let's delete this one. It's either you delete or you can change the status. For instance, If you click on it, it will open the item details you can edit. So let's change the status from processing to closed. You can just say CL. All right, so let's save this. Now the status is closed. So if we go back to the table, we can see right here that the status, return status has changed to CL, which is closed. And so likewise, you can delete. If you want to delete, you can click here, right here, and click on delete object, blah, blah, blah. So you click on delete and then it's gone, it's deleted, right? So in the create mode, let's say, okay, let me put it in the edit mode. Let's say this value and let's edit this. So if we put a negative refund value, let's say minus 2999. And when you save this, so it's still accepted. The value is the negative value is still accepted. So this is not okay in normal functionality because you have to control this, right? And this is happening because we have not added any business logic. And that is what we are going to do next. So to add business logic for verifications and what can be edited, what can be updated, what can be deleted, we need to do this using entity manipulation language, which is adding the ABAP language. Which is adding the ABAP logic. Okay. So these are the 6 steps for publishing your OData service and previewing the app. You open the service binding, you activate, you click on publish, you select the entity, you click on preview, and then you test the CRUD operations, you create, you read, you update, and you delete requests. So no business logic yet. All right, so let's go on now and we add the ABAP logic, which is called the entity manipulation language. So the concept of entity manipulation language, so EML is a special set of ABAP statements that is actually designed specifically for the RESTful ABAP programming, which is called the RAP model. So when you are inside a validation or a determination, your business logic will not just go directly to the database. Okay, so instead you are communicating through something we called the transactional buffer. So you should see the transactional buffer like a temporary workspace that will hold the user's current in-progress changes before they are finally committed to the database. Now, the entity manipulation language actually gives us 2 main statements for working with this buffer. And the first statement is what? The read entities. And the second one is the modify entities. Follow me carefully now. So the read entities, what this does is it will read data from that transactional buffer. So you use this in determinations when you have maybe, for example, calculated a derived value and then you want to store it back. So the read entities, what happens is this will read data from the transactional buffer. So when do you use this? You will use this to get maybe values that the user has entered so you can check them or use them in calculation. So this is where you use the read entities. Now for the modify entities, it is used to modify or edit data to the transactional buffer. So you use this in determinations when you have calculated a derived value and want to store it back, okay? And then you almost always use the addition in local mode. So with both of these methods. So this actually will bypass authority checks during internal processing, which is what you want when your own code is calling itself, all right? So now, before we can actually implement any logic, we need to declare it. So in the RESTful model, what happens is you declare your validations and determinations in what we call the behavior definition. All right. So this is how the behavior definition looks like. So let's go to Eclipse. So let's open our behavior definition for this our business object. Behavior definition starts with ZR. So we come to behavior definitions right here. So this one, you can see ZR return request 2. See behavior definition for our ZR return request 2. So double click on this. So we can see how the behavior definition is using a managed implementation. So managed implementation means that the functionalities are automatically handled by SAP for us. All right. So at the moment, you can see the functionalities it can create, it can update, and it can delete. So these are the methods that our business object can carry out. So that's why it's called behavior definitions, the actions that it can carry out. So then we can also add 3 validations and one determination. Validation and one determination. So validation means what? To carry out validation. All right. So we can see here, define behavior for this. And this is the table that we are defining the behavior for. And this is our draft table. Our e-tag master, local last change that. Then also for the log master, we can also add this. So authorization is global. And these fields will be read only, return UID, UUID created by, so it will only be read, you cannot update it. And you see that this return UID, the number is managed, so it's determined by the system, not by you. And we have this method create, update, and delete. So our draft actions are activate, discard, edit, resume, and then prepare. So these are the draft actions. And for mapping, we have our returning UID is mapped to this, customer ID is mapped to this, order ID is mapped to this, and so forth and so forth. All right. So let's add our validation under this one. So validations means that checks, So we're going to create validation to validate refund amount, to validate customer, to validate return reason. All right. So this is you write the keyword validation, then write the variable or the method name. So validate refund amount on save. So when you click on save for the field, that's an in creation mode for the field refund amount, is going to trigger this method. Likewise, validate customer. So when you click on save and then you are in create mode, what field? Customer ID is going to run a validation checks on customer ID, and then likewise validate return reason on save in creation mode. Which field are we validating? Return reason. All right. So, and of course, you're going to get error that this does not exist yet. So we need to create this method. Now we can also add determination. So the determination will run on modify, okay, meaning that whenever the record is created or changed. All right, so let's create this. So you can create them by just saying Ctrl+1. All right, Ctrl+1, it will tell you add all 4 missing methods. Add method of validation. So you can just do all at once. So let me just click add all 4 missing methods for a quick fix. So it takes us to the business behavior definition class for our return request. So you can see you are already familiar with this. So we have private methods. All right. So the main purpose here is our methods. So let's start with the validate customer. Then you see here validate refund amount. You see here validate return reason. So what are we validating for on save? So we actually need to go to the implementation part actually. So let's start with validate amount. All right, so let's walk through what's happening here. Okay, so we start with the read entity statement. So this is the read entity statement, and then we specify the business object. So which business object are we reading the entity from? And that's the ZR entity. So you can go to your behavior definitions. So anyone that has with R, that's your entity. Okay, and then we specify the in local mode. So, and we will tell it to read the refund amount field. So that's why we say fields. Which field are you reading? The refund amount, and also there has to be currency also. So these are fields that we are reading, and they with corresponding keys. So this part means that we read the records whose keys are in the keys importing parameter. So those are the records that the user has changed. All right. So we are reading the records which the user have changed here, and then we pass the results to data. So we then loop through the results. If the refund amount is 0 here, we are looping through the results. Result is passed here. Loop at return request into data return request. So if return request and then the refund amount is less than or equal to 0, we tell the framework that do not save this record. Okay, so now we are doing two things here. First, we add the records key to failed return request. So this is the record key we are defining here. We then add it to failed return request. And then the second thing is that we tell the framework to show these error messages. So we add an entry to reported return requests. All right. So this is how we send the message back to the user, and we create a message object using this one, this new message. We are creating a message object here. So with ID, Z return messages. So we are going to create the number 001. We are going to create this severity error, and then And then this last part will just highlight the field in red. Okay, so now, this is the same code I'm showing here, the validate refund amount implementation. So the percentage TKY field group is what understanding. Because it's a shorthand for the full technical key of the record. So the client and the UUID together. So using this percentage key and then TKY, it is safer and more readable than just addressing each key field individually. All right. So it's a combination of two key fields we are trying to access with the percentage TKY. So of course, we need to also create a message class because we are saying we attach the new message here. So we need to create the message class. So before I create a message class, let us just finish with the second validation. The second validation would be to validate the customer. It will check if the customer exists. All right. So the structure is similar to what we already did. All right. So let me show you in Eclipse. So validate customer if the customer exists. So we go to the implementation for the validate customer right here, and then we're going to write our code. I'll just paste the code here and then explain. So for the validate customer ID, of course, we are reading which entity are we reading? The ZR return request to entity. And then what field are we interested in? The customer ID. And with corresponding keys means the current field that the user is working with, and then return our results to return request. So we are looping into the result that we have into this work area. And so we read the customer ID field. Then for each record, we do a select single against the CDS view. So in this example, Z1 underscore customer, and we are checking whether the customer exists. So if the customer exists, that's if SY sub RC is greater than or equal to 0. Or let me say if SY sub RC is not 0 after the select, the customer was not found. And so we'll just fill the field and reported structures just like that. And you have to notice that we are reading the CDS view entity, not the database table directly. All right. So we are reading the CDS view entity. We are not working with the database directly. So this is the right approach in our RESTful model and always stays in the abstraction layer. And then we append the error messages one more time. So we'll create an error message class for this later. And finally, okay, so there's one important mistakes that I should take note here. In this loop, we are running a select statement. So because it's for learning purposes, okay, but in real production, you should not do this. So in production, what you do is you will collect all the customer ID first and then do a select single for all entries in order to avoid performance issues. So that's the best approach. So this method set default status. I get some intelligence here. Yeah, so we just also update the set default status code. Yeah, so we also update the set default status code. So let's do a fix quick for this. The determination is here. So let's see. Yeah, and likewise, we just also write the code for our validate return reason. Yeah, so you can just ask for the code if you're interested in seeing the code on how to validate your customer, validate customer. We also validate the price, validate the refund amount. So just leave a comment in the comment section and I will post it there for you to have a copy of it, or you can just write your own code. For now, I'll just remove the validates return reason. Let's see, can make the other one to work first. Then you can add, okay, so let's predict it using AI. So let's also remove it from the behavior definition. We created validation here. To validation, we need to add them to draft determine action prepare. So add those determination here also to avoid error. Yeah, so these are just the method the validation we're going to be working with at the moment. So validate refund amount. So on save during creation mode, and the field is refund amount. The field is refund amount, and then the validation, the method called validate customer. When we are saving and in creation mode, the field is customer ID. Determination is set default status on modify. So when you are modifying, use default status. Then our draft actions, activate, discard, edit, resume. So we need to also add this draft determine action prepare. So validation, validate refund amount, and then validate customer. You pass in or you map the values. So if we go to our class, let me control save this, let me activate. If we go to our class, we need to implement these methods. So you will see here, set default status, validate customer, validate refund amount, and then the customer the method implementation. So this for the set default status and the customer implementation for valid customer. Likewise, method implementation for valid refund amount. So you can also add another method, validate return reason. So let's activate this. So once these are activated, what we do, let's go and refresh the screen and see if our validation is working, especially for the price. Refresh the page, it's still loading. So let's check the price. If we enter negative number, if this will work. So let's go on edit. At the moment we still have minus 299, so let's say minus 229. So if we save, so you see here that resolve data inconsistency or save changes. So there's an error which we need to maintain in the error messages. All right, so resolve data inconsistency because you are not supposed to put negative value. Yeah, so and then what other one, customer ID. Let's see if we can create another customer with this same ID. So it should not, anyway, before I go, okay, discard changes here. So click on discard. Before I go further, let's just create the message classes so that we get good messages on the UI. So to create a message class, so let's see my package. So just right click on the package. You can just go to new, go to other repository, ABAP objects. So search for message. You see message class here. Next. So here we give a name to it. So we can just say return request error messages. So click on next, click on finish. So here you can enter the number. All right. So for our number we have for 001. So what will be our short text? Refund amount must be greater than 0. Okay. So what other message class should we create? So let's say 002. Customer ID already exists. Of course, you can also use placeholders for this. So let me control save. Let's save this and let's control F2 check, control F3 to activate. All right. So let's go to our Fiori application again. So let's try to create a customer ID, create a new customer. We have one of the ID to be C1007, product ID. Let me just see, E5 computer 4534. The reason, let's say defective, quantity 1 or 10, return status open, order ID. All right, so let's click on create and see. So you can see that customer ID already exists. The phone amount was greater than 0, so this is not supposed to be showing here. All right, so refresh the stuff, refresh the Fiori app, and let's see all our data. Let's try to edit. Click on one, click on edit, and let's put a negative value here for our price, and let's see for our amount, and let's see what we get. So refund amount must be greater than 0, which is okay. So we need to close this. So let's clear this and then click on save. So now object is saved. So if we go back, so see that we have C1001, right? So let's see if we want to create a customer ID, and we'll now type C1001. Just put some random order ID here, product ID, refund reason, let's say defective, quantity 1, open. We need to select date. Let's click this on this, amount 200. All right, so let's create. Click on create. So we are getting customer ID already exists. as the error that we have. So you have to close it. Each time you get an error, you need to clear them so that you don't get errors from previous messages. So close this right here and then come over here and close it. So this customer ID already exists, so we cannot create anymore. All right, so this is how far we'll go with this. So in upcoming videos, we can just make some adjustments, make the UI to look better, and yeah, so this is how you can create your RESTful ABAP programming application and also using entity manipulation language in modern ABAP. If you are new to this channel, please don't forget to like this video and please subscribe to encourage me to make more videos, and see you in the next video.